Testing 1 2 3. Testing 1 2 3. Testing. Testing 1 2 3. Sorry about the wait, guys. Just about to get started here for some Python programming. We're still kind of new to doing programming streams here on the channel, so I apologize if it's a little bit awkward while I get things sorted out. Here we go. So let me play with this a little bit here. I thought I was ready, but I'm not quite. That'll do. Let's save this as Python Day 3 classes. Okay. Yeah, sorry about the wait, guys. Aha! Aha! Sorry, guys. Making you some new buttons. I assume you're attached to the color scheme thinger. Thank you, Bones. Some new buttons. Not sure I totally understand, but I appreciate the thought, though. Wendy's is the job. Nice, man. Okay, sorry about the wait, guys. It's it's Python. Let's do it. We're in there. Guys, if you guys are new to Intro to Python, you might not realize what we've been doing lately is we've been making a Pokemon clone of the original Red and Blue Game Boy originals. The classic Pocket Monsters games. And I've been using that as a vehicle to talk about the very basics of programming, not the advanced stuff, not like, oh, you've been programming C++, but here's how Python works. We're talking about, like, you're totally new to Python, you've never programmed before in your life. So, like, how does programming work? How do programmers think? That's what we've kind of been talking about, right? In the past episodes, we got a fully working version of Pokemon here. So this version it's not a fully working version of Pokemon. It's a fully working example of a Pokemon battle. Let's put it that way. It's a very simple program. It's about 200 some lines, and it's pretty neat. I'm very proud of it. So why don't we look? I'm starting to see that we have some scrolling going on here. Well, poop on me, dude. Poop on your boy Vencabot, please. It's okay. We'll fix that later. I'm making some new panels, huh? I'll send you a sample in a second. Thank you, Bones. Yeah, if you want, I can put it on Discord. I can check there a little bit easier. Yeah, good luck, Alnyrus. Good luck with work, man. That sounds pretty exciting. Okay, so before we go on to today's topic, which is classes and object-oriented programming, let's talk first about how our program is working right now. In fact, let's run it first. So we're using idle now. In our last episode, we used Notepad. Now we're using the idle code editor, which comes with Python. If you want to run your code in this, all you got to do is go up to Run and click on Run Module, and boom, get a nice little window here we can run your code. How does that look for you guys? I think it should be okay. Okay, so let's see here. What move should Cyndaquil, it's going to be Cyndaquil here, not Cyndaquil. So first we get this move list for both of our Pokemon, right? So Cyndaquil is our character. His available moves are Tackle, Flamethrower, Tail Whip, and Growl. Our opponent is Squirtle. His available moves are Tackle, Bubble, Tail Whip, and Tatsumaki Senpuken, which is a move from Street Fighter, of course. So what move should Cyndaquil use? Well, first of all, let's try and have him use something he doesn't know. Let's have him try and use, I don't know, Metronome. Right? If we can spell it right. Boom. Okay. So he doesn't know that move, right? So he asks us again, what move should he use? Well, let's have him use Flamethrower. Right? Why not? Okay, we have some messages here, right? It says, Cyndaquil blew flames at Squirtle. Squirtle took 4 damage. Squirtle now has 64 HP. Flamethrower has 4 PP remaining, so it started off with 5, I guess. Now we say here, Squirtle executed a whirling kick at Cyndaquil. That's the Tatsumaki Senpuken. Cyndaquil took 10 damage. Cyndaquil now has 45 HP, and Tatsumaki Senpuken has 665 PP remaining. It actually started with 666 PP. Okay, so now I've lost health. I'm at 45 health. He's at 64. He's got more health than me, right? So that did pretty good damage there. 10 damage. I can't keep taking that. Why don't we use Growl, which lowers the opponent's attack power, right? Okay, so Cyndaquil growled at Squirtle. Okay, so Growl has 7 PP remaining. Now Squirtle did another Tatsumaki. Fuck. So now I took 8 more damage. I got 37 HP, and he still has, a 64. All right, so why don't we Growl again to reduce his attack power a little bit more. Okay. So I growled at him again. I got 6 PP left. Squirtle blew oily bubbles at Cyndaquil. It's super effective because it's water type, even though it's oil. I took 6 damage. I now have 31 HP remaining. And now his bubble has 5 PP remaining. Well, poop. I'm definitely losing this fight, looks like, so far. Well, why don't I try Tail Whip to lower his defense? Okay, so I whipped its tail at Squirtle. Nice, nice. Whip my tail at him. He's bubble again. Fuck. Can you check what moves you have? Yes, it actually tells me at the start what moves I have up here. I've got Tackle, Flamethrower, Tail Whip, and Growl, and he has Tackle, Bubble, Tail Whip, and Tatsumaki Senpuken. Okay, so let's see here. So I've got 25 health left. He's a Water type, I'm Fire type. It's not a good look. So last time, remember how you ran out of PP and couldn't kill? Yes, I remember that. Yeah, we're gonna have to add an ability to like struggle, right? But if you just want to check like now instead of scrolling up, no, you can't. Not yet. Not yet. You certainly can. If you don't want to scroll up, you're pretty boned. We can fix that later, though. There's actually a bug in this too. There's a bug right now in this code where if I run out of PP, let's say that I use up all my flamethrowers, right? Then I get asked again what move I want to use, which makes sense, right? I try and use flamethrowers. Like, you're out of PP, dude. Pick something else. But due to the way we we kind of copy-pasted our code for the opponent, Squirtle. If he runs out of PP and tries to use a move, he's got a random move choice. If he picks a move that has no PP left, it skips his turn. So interesting bug there too. We've got a few bugs here, but it's mostly working. Okay, let's see here. So what move should I use? Tackle. I haven't used that yet. Okay, I tackle him. He's got 59 health left, and I've got however much health left. Let's see here. Where is it? 31 HP. Okay, well I'm about half dead already compared to him. So why don't we use Tail Whip again to lower his defense? Oh, another Tatsumaki? Fuck, I'm at 18 health already. Okay, let's do one more Tail Whip. I'm down to 11 health. Let's do a Tackle. I got 8 health left. He's got 52 health left. I'm going to tackle him again. I got 1 health left. He's got 45 health left. This is going to be it, guys. Boom. Game over. So it says here that Cyndaquil has fainted. Squirtle wins, right? He blew that last bubble at me. I got -6 health. I'm knocked out. Boom. Game over. Okay, so now we've seen it run. Let's look at how it works. Right? It's pretty simple. I want to go here. I need to close this. There we go. And look at this. Okay, so the first thing we do is we import a library. Right? We import the random library here. That means that we can use random number generation, which we use for Squirtle's AI. And it's AI, but really it's just him picking a random move, right? So we use this random library to use some of the methods or the functions built into it. That's kind of cool. We define our own function right off the bat. We define a function called deal damage. It takes 3 arguments: the opponent's name, the opponent's HP, and the actual damage we're going to be dealing to the opponent. Right? So every move calculates its own damage, and then we feed it to this function here. This function is very simple. All it does is make sure that actual damage is a positive number, because if damage is negative, it will heal the opponent. Right, let's say we're going to be let's say we have a tackle that would do 10 damage, right? And the opponent has 12 defense. Well, the way we calculate defense now is very simple. Every point of defense just subtracts 1 point of damage. So we'd have a 10 attack power and 12 defense. That would be -2 damage. And then we'd be healing our opponent with tackle. Right? So to prevent that, we have this very simple if statement. If the actual damage we fed in right here as an argument is less than 0, then we make it equal 0. So if it's below 0, just make it 0. Right? Don't make it anything less than that. Then we actually do the damage, right? So we take the opponent's health, and we say whatever it was before, subtract our damage from it, and then save that as opponent's health. Right? So now, let's say he starts off, let's say he has 20 health, we just did 10 damage, right? So we're saying, hey, listen, now your HP is now 10, right? So your old health was 20, minus our damage, which is 10. Now you have 10 remaining. This is your new HP. Let me print off some messages for the player here. The opponent's name, that would be Squirtle, took some amount of damage, right? Now you can't add a number to a string. You cannot insert a number into a string, at least not using this method with the simple plus sign. There actually are ways to do that. We're going to learn later on. Right now we're just using plus to combine all of our words together. So we have to use this str function, which will take a number or any other kind of data and spit out a version of it that's a string. So that way we can turn, like, let's say the number 15, which you can do math on, to the characters 1, 5. That way you can't do math on it, but you can add it to strings. So there you go. Now we're going to say opponent took 10 damage. We print off here, the opponent now has some amount of HP remaining. Cool. Then we return their new health. Right? So we did some math on their health, and we want the game to save that new health. Right? We want to say you did 10 damage, make sure that your Squirtle's HP gets updated. So we return that health back to be used as an assignment later on. Right? Assignment to a variable, to Squirtle's health or whatever. I know it sounds a little bit complicated. We're going to make it a lot simpler today by using classes. And speaking of which, guys, speaking of complicated shit we're going to make simpler today, we also have all these loose variables up here where we define the attributes of Cindidix and Squirtle. So each Pokemon has its own set of attributes here. And we start off with the name, right, which is a string. Now, when you say a string in a programming language, what you're referring to is text, right? A lot of data here is like numbers and stuff. Here we have a list, which is like a list of data. But a string is just text, and they start with quotation marks and end with quotation marks. It was up, Locust. Vencabot. Vencabot. So we save this Pokemon's name, the first Pokemon, Pokemon 1. His name is equal to a Cindidix, right? Meanwhile, down here we have Pokemon 2's name, that's Squirtle. Pokemon 1's type is also a string, it's just fire. Likewise, down here, Pokemon 2 is a water type. Then we have a bunch of numbers, right? We have the Pokemon's HP, attack power, defense, and the amount of PP they have for each of their moves. You know, so move 1, that would be tackle, that's 10 PP. Move 2 is flamethrower, that's 5 PP. Move 3 is, you know, it's whatever. You guys get the idea, right? They have their own PP amount. And in Pokemon, every time you use a move, it reduces its power points value. And once the power points reaches 0, then you can't use that move anymore. It's exhausted. It's kind of like ammo, basically. Think of it as ammo per your moves. Then we have a list, right? This is a list of strings. Now, in our last episode, we touched on lists for the first time. A list is a organized group of data. You could think of it like, right? And it starts off and ends with square brackets. And each item in the list is separated by a comma. In this case, we have a list of strings, right? So all these strings represent the name of each of his moves. Tackle, flamethrower, tail whip, and growl. And the reason we're using a list here is because we have some random number generation functions that will give us a number between, 0 and 3. This is spot number 0 right here. 0, 1, 2, 3. It picks a random number between, in that range, and then picks one of these moves from the list at random for Squirtle. That's why we have these lists here. Okay, so once we have these Pokemon defined with all these loose arguments, these loose variables, then we start printing off data for the user to see what moves they have. Right? So as you can see here, it's got, this is a simple bunch of print statements to print off messages. Now, every time you use the print function, you put whatever you want to print on the screen as an argument that goes between the two parentheses. That's true of any function. Right? You can feed in data by putting it between the parentheses there. The data you feed in gets put on the screen, and every time you run print, you get a new line. So each of these goes on a different line. So we have, Cindidix available moves are tackle, flamethrower, tail whip, and growl. We actually indented it here to make it a bit easier to read for the user. We do the same thing for Squirtle, even though in real Pokemon you wouldn't know the opponent's moves. But we just did it there just to make it symmetrical. Okay. And then finally begin the actual main combat loop. Before we do that, I'm going to adjust some volume on this music here. I'll be right back, guys. I see the music is actually much louder than I expected, in general. For you guys, it's not that loud right now. But behind the scenes, there are technical difficulties with this. I'm actually going to lower this volume quite a bit, down to like here, and then raise it over here. Okay, that should be a little bit better. Guys, we're enjoying the music of my friend Albdat.
So skanky.
If you want some kind of moody, creepy, cold sounding music to program to, check him out. Okay, sorry about the wait, guys. Okay, so let's see here. That's at aubdat.bandcamp.com, AUBDAT. .bandcamp.com, AUBDAT. Very cool guy, free music. Thanks for the follow. What is this? Nebulosa TBH. Welcome aboard. Do you have any questions? Please let me know. We're making a little Pokemon battle example here today. Now, previously we've been avoiding classes. I've been trying to teach the very basics of programming without bringing in any object-oriented programming. Today we're finally going to take our existing code, which is very sloppy, and make it a lot cleaner using classes and objects. But first, we're going to go through this code as it is now. So after we've defined the Pokemon up here with all these loose variables, and then printed some data for the user, we enter our main combat loop. Now, a while block, right? All this indented code here is within the block. It defines a condition where this loop will always repeat. Oh, thank you, Nebulosa. I appreciate that, dude. I put a lot of work into this channel here. I'm glad you're enjoying it. So Okay, we have this while block, right? And it has this condition for us. Now the condition here says, if Pokemon 1's HP is greater than 0, and Pokemon 2's HP is greater than 0, then you have this little, little colon there, means do all this junk. Love G-type? I love Python too, dude. Such a beautiful language. Do all this junk. So it says, as long as both Pokemon are still standing, as long as they both have their HP above 0, then keep on doing this combat loop. Right? So it's kind of like an RPG, right? You take turns going back and forth. Keep on doing that until somebody faints, is what we're saying. So here's how the combat loop starts. We print off a blank line right off the bat to separate from all this text up here and separate each turn. Then we say, hey, listen, what move should, Syndedix use, right? What move should Pokemon 1's name use? And this input function is a very basic function. It's built into Python that asks the user for some textual input. So it puts on the screen this prompt, right? The argument here is the prompt. It says, what move should Syndedix use? And then whatever we input gets returned into this value here, inputted text. Right? So whenever you have a function that returns a value, you can actually assign that value to a variable by doing it just like this format here you see. You can do that for anything, right? You can actually do it for, like, hypothetically speaking, you could say, our sum equals sum, 2, 4, right? I think sum is not actually, that's not how the actual function sum works, but you get the idea. So basically what we're saying is that, hypothetically speaking, if sum was a function that added 2 and 4, then our sum would be equal to 6, right? Because this function here takes two variables, or takes two arguments, and then returns, the sum of them into our value here. That's true of any function. You can assign, basically you use functions as a way to assign data. In this case, we're using input, and we're giving it this prompt as an argument, and we're getting back whatever the user typed in, which is kind of cool, right? So we're getting a name of a move here, hopefully. And now, once we get that name of that move, we're comparing that move name to all the moves we know. Hey, what's up, Austin? How you doing, dude? Hope you're having an awesome day. So we have this big bunch of if and elif blocks, right? We're saying if the text entered was tackle, then here's a bunch of indented stuff here. It says do tackle, right? If you typed in tackle, then do tackle. All that code there is like the code for doing tackle. In fact, we can look at it right now. It says if Pokemon 1's move 1 PP, so if tackle is out of PP, right? Equals means is equal to, because the equal sign, only one of them already means assignment. That's for a variable assignment, but two of them means is equal to. So if Pokemon 1's move PP is equal to 0, then print off a message saying, hey, listen, tackle has no remaining PP. It's all empty, right? It's empty. And then continue. Now, continue is a special statement used within loops. It can be used within a for loop or a while loop. In this case, we're using a while loop, right? Continue means go back to the top of the loop. So in this case, we're saying, if you have no PP remaining, then don't even do anything else. That's all. This is now worthless, right? All this shit down here is pointless. Go right back to the top. That's what continue means. So it goes right back to the top, prints off a blank line, and once again asks the user what move they want to use, right? So if you're out of PP, go back to the top. Austin says, what's the old school RuneScape event today? That means we're going to be playing old school RuneScape, bro. You're welcome to play if you want. Thank you, Bones. I'll look at that in a minute. We're going to be playing some old school RuneScape, man. Me and the squad. You want to play, Austin? You're totally welcome. You play old school RuneScape? Do you have a character around level 60? Or lower? You can even make a new character. I don't care. Okay, so first thing we do with any of these moves is we find out if that move has any PP left, right? You can see that here for Flamethrower as well. It's the same thing for Tail Whip, right? If they have no PP left, then make sure the user knows and then go back to the top. Easy. Then we need to actually do the code for Tackle or for Tail Whip or for Flamethrower, right? We say, hey, listen, first of all, we print off a message, right? Pokemon 1 name, that's Syndedix, tackled Pokemon 2 name. So Syndedix tackled Squirtle. Then we calculate damage. Now for tackle, it's very simple. We just take Pokemon 1's attack power, which would be, whatever Cyndaquil's attack power is, and then we subtract the opponent's defense. So if Cyndaquil has, 8 attack power and Squirtle has 4 defense, then we do 4 damage. We subtract 4 right from it. Now I'm sure in the actual Pokemon game, there's a much more complicated equation for using defense. In our case, we're making it very simple. Defense simply absorbs damage. One for one. Awesome, since I haven't played RuneScape in years, I don't even have I'm not even sure I have my account still. That's funny. I'm going to go do the event with you guys on my main so you can worship my godlike account. Let's go, Faust. So I don't care. It's all the same to me, man. We're just here having fun, basically. Yeah, high-level people, yeah. Yeah, I don't mind having strong accounts help us out. I don't think it subtracts too much from the experience. Okay, so once we've calculated our damage, then we use that function we made earlier. Remember this function, deal damage? Let's go review deal damage, right? Right up here. Deal damage. Now, deal damage takes 3 arguments. The opponent's name. That way we can print off this messages here, right? It needs their health as it currently is, and it returns their new health. It basically deals the damage out. And it needs how much damage it wants to deal. Right? So you feed in how much damage you want to deal, and it does the damage and gives you back the new health. G-types, it's actually that simple. The calculation for getting the defense of the Pokemon, and if the attack hits or misses, is a bit more complicated. For getting the defense, oh, I see. Well, don't they have like a defense stat? Maybe I'm wrong about that. In any case, yeah, I'm not a huge Pokemon nerd or anything. I played through the Game Boy game Pokemon Yellow kind of recently on stream. But yeah, in our case, we just have a very simple defense stat that just subtracts, damage. So we use a deal damage function here, right? We feed in our opponent's name, which is, Squirtle. We feed in the opponent's health. And then we feed in, the actual damage that we calculated right here. Right. Cool. And then we get back another value. Remember I talked before about how you can enter arguments into a function. And then that function can give you data back, but you can assign to stuff, right? In this case, we're assigning Squirtle's HP to this new value returned by deal damage. So deal damage, changes this HP value and gives us back a new value. We're saving that value as Squirtle's new HP. Right there. It's a static number, okay. Oh, same account, but you have to make a new character, huh? I gotcha. Gotta make a new one for old school. Sick, I hope you can join us, Austin. We're gonna be playing it all night long. You can come in anytime you want or leave whenever you want. That's true of everybody. And we reduced the PP by 1, right? So basically you've used tackle now. That means it's, it uses up ammo. So we're saying, hey, listen, the new PP for move 1 is whatever it was before, -1. So if it was 10, now it's 9. And if it was 9, now it's 8. Then print off the new PP, right? That way the player knows how much PP they have left. Tackle has, some amount of PP remaining. And once again, guys, you cannot add a number to a string. So we can't just say, tackle has move 1 PP remaining. That'd be convenient, wouldn't it? But you cannot add strings and numbers together. However, you can actually convert that number, or in this case, copy that number to a string form with this function str. So str will take a number or any other kind of data. Let's say the number is 10, right? And you can do math. You can add 1 to 10. You can add 2 to 10. It takes that number and turns it into characters, which can be printed on the screen. So it'll take the number 10 and turn it into a 1 and a 0 side by side. So it's pretty simple, but kind of unusual. As you learn to program better, you're going to learn about F strings and formatting. That makes this a lot easier, right? But in our case, we're still just adding strings together with plus. It's very usable for beginners. Nothing wrong with that. Okay, so we also have flamethrower here. Now this one actually can do extra damage, right? So here, before we actually calculate our damage, we figure out what type the opponent is. So in flamethrower's code, we say, hey, listen, if Pokemon 2's type is grass, then print off it's super effective, right? Because it's fire. Fire burns grass. And then we actually calculate the damage double. So Pokemon 1's attack times 2, right? So it does double damage minus the Pokemon 2's defense. So it won't quite do double damage because of this whole defense attribute, but yeah, it does pretty good fucking damage. If it's not grass, I usually say else here. If it's not grass, then just do regular damage. Right? Pretty simple. And the same code here, for dealing damage here. Then we change the PP around. Very, very basic stuff. But before I go any further, guys, let's talk about code blocks and conditions real quick. So here, when the user inputs their command, the first thing we do is we say, hey, listen, if that move is tackle, then do this. I'll do all this code here. But then we say, Elif that text is flamethrower, then do this. Elif that text is tail whip, do this. Elif that text is growl, then do this. Else, do this. Okay, let's talk about that for a second, guys. So, the way that if blocks work is you write the if statement, and then you provide a condition. So we say inputted text is equal to tackle. So we say if the text is tackle, then execute this code, right? But if that's not true, right, then what happens, right? Well, if it's not true, then this code won't run, for one thing. We can do a very simple code right here. For instance, we can say, let's just do a little example here real quick. Actually, I have a blank page here somewhere. Here it is. We just say, my name is, David, because it is. Then you can say, if my name is equal to David, then we can print off, hi, David. Easy, right? Then we can, print off, bye. There you go. Right, if we run this code now, what's going to happen, guys? Well, we know that my name is David, right? It says it right here, my name is David. So we're going to print off hi, David. Then we're going to print off bye. Right, let's actually do that real quick, if you guys don't mind. Run module. Boom. So we get a couple messages there. It says hi, David. says bye, end of the code. Very simple. But what if our name was, you know, John? What if our name was John instead? Well, here's what's going to happen, guys. This code will not run. This indented code here as a part of the code block will not run because, you know, it only runs if my name is David. However, we will still get bye because bye is not inside the code block. You see how it's not indented anymore here? There's no indentation. That means that this is the code block. This will only run if my name is David. But this code will run regardless. It'll run regardless. Right, so we're going to get just bye here. Let's just run this code here. Run module. Okay, all that happens is it just prints off the word bye. Right, pretty simple. So Nebulosa says, in Python, the triple equal exists. If so, can you explain the difference? Geez, I've used so many languages, Nebulosa. I'm not sure that it does exist in Python. I think it's more of a JavaScript thing. But if I'm not mistaken, doesn't equals just mean it's the same object? Or am I wrong about that? Now in Python, we have a thing called is that I know isn't in JavaScript. What is does is it's not satisfied if the codes are equivalent. It's only satisfied if the two objects are the same exact object, right? So what we can do here is we can say, like, what's a good example? I think, can we do, I'm not sure if we can do this. I'm not sure this will work. Let's try it. I'm not sure if this will work or not. But we can say, you know, my name is John, and your name is John, right? So we can say, you know, if my name equals your name, then print off, you know, you're both named John, right? It's a strict equality. So I saw examples about null and zero values. Yeah, null is a singleton in Python, which means that there is only one null ever, or excuse me, one none in Python. I think null is the same way in JavaScript. But basically, the idea is that I think equals the same thing, but it means that it's not satisfied that they're the same value. They have to be the same exact object. They have to be not copies of each other, not identical to each other, but the same exact, you know, object conceptually. So in this case, we can say, you know, I mean, I'm not sure if this will work, but our names are the same, right? They're both John. So this will work. My name is your name, right? We're both named John. Let's run this. There, so you're both named John, right? But if I put is here, if my name is your name, then it won't run, because although we're both named John, let's see here. Oh, it still works. Well, I fucked up then. I guess because that's the way that literals work. Yeah, I don't really have a really great example for is. Is is really mostly used for singletons in Python, which we're not really there yet. We're kind of a beginner course here. But in Python, there is a value called none, which is very much like null in JavaScript, right? With this none value. And although you can assign none any number of times to any number of things, none is always the same object. So just like your example, Nebulosa, in JavaScript, none may be equal to 0, right? They do the same value, essentially, but none is not 0. So if you're really testing just for none, then you want to use is. So you say, you know, if my name is none, then do this code, right? But you say, you know, if my name is equal to 0, you know, none might be equal to 0 or whatever, but it is still just none. So really, is just more specific in terms of what object we're talking about conceptually, right? Equality doesn't necessarily mean that they're the same object, right? Just like, you know, me and my brother might be, you know, socially equal, but I mean, we're not the same person, right? That's kind of how you use is. I think JavaScript is the same way with equals. Anyway, let's go back to this. I'm sorry if that was a little bit unclear. I said we're not really there yet in terms of where we're at in this lesson. So Austin says, it was difficult for a decision for me because I disliked the game in its current state, but I couldn't resist playing it. Were we talking about WoW? Okay, guys, so where were we here? We're talking about, oh yeah, Elif and if blocks, right? So we're learning about if blocks. And actually, I can go back here. I had an example going here about people's names, right? So we're basically going to learn about how else works real quick before I go on too far. So we have, you know, if, let's just say, you know, my name is David. Then we say, you know, if my name is equal to David, we print off, you know, Hi, David. Then we print off bye, right? And we established before that if my name were equal to John, right, let's say we assign the name John, this code will not run. However, you can use an else statement, right? Let's use an else statement here. Else, print, hi, whoever you are, right? So here's what happens here. Now we established that if this line is not true, this code will not run, right? And then we get this stuff down here, print by. However, if you include an else statement, what this means is that if this code is not true, then this code will run, otherwise it won't. So in this case, by runs either way. Right? The code by runs either way. And this code will only run if my name is David, and this code will only run if my name is not David. They will never both run. What's up, here goes? So Nebula says, thank you. It's not easy comparing programming languages features without testing first. Oh, no, of course, Nebula says, always a pleasure. I appreciate all the questions, dude. I really hate JavaScript. It's a really gross language in terms of how it behaves. There's not a lot of consistency there, but I do appreciate it a lot as a really powerful language. I think JavaScript's very important to learn. I'm glad that you've been learning it. So here goes. What do you think about it, man? That's my only question, is what do you think about it? How are you enjoying Red Dead 2? Hopefully you're enjoying it a lot. Okay, so let's talk about Elif, right? So Elif is basically a combination of else and if. Hey, let's go, here goes. Yeah, gross but powerful, Bones, yeah. Gross but powerful. So basically we can say, else if my name is John, then we can print off, hi, John, right? Then we can say else, if it's not John either, we can say, well, if my name equals Steve, we can print off, hi, Steve. You guys get the idea, right? So let's actually look at how this works logically. So what's happening here is that we're saying, if my name is David, then do this. If it's not David, is it John? If it is, do this. If it's not John, right? We already know it's not David, because we're already in this block. We're saying, if it's not John, then is it Steve? Well, if it's Steve, then do this. And then finally we can say, else, print, I don't know who you are, but hi. Right, so we're finally saying, listen, if it's not David, and it's not John, and it's not Steve, then just print off, I don't know who you are, but hi. Right? We only know this many people. Now, as you can see here, we're getting a lot of indenting, right? Because every time we do another else, we have to indent again. Then we have to do another if, indent again. So thankfully, Python provides this tool called Elif, which is very simply an else followed by an if, just like this. Right? So it says else and if. Well, we can just do Elif instead. We can say Elif, my name equals John. And now it saves us some indenting. Right, so we actually indent it right here. Right, then we can say, Elif, my name is Steve. Right. What else? We saved a lot of indenting now. We can finally say else. Right. So here's a very simple Elif block. Right. So if my name is David, run this. Elif, my name is John, run this. Elif. So saying only run these if the previous statement is not true. Right. So if this isn't true, then ask again. Is it John? Well, if that ain't true, then ask again. Is it Steve? And if that's not true, then default to whatever message. If nothing is true, then default to that at the very end with the else statement. So let's go back to our code here and see how we use that in Pokemon. Right. Now in Pokemon, we use that as a way to test moves. We're saying, if they inputted tackle, then run this. If they inputted flamethrower, then run this. Else if they inputted tail whip, run this. Else if they inputted growl, run that. Else, so if they didn't run any of that stuff, then ask them, tell them they don't know that move, right? We only know those 4 moves, so Synthetix does not know that move. Then we continue back to the top and ask them again what move they want to use. Like leprosy, that's that powerful. Best looking game on PS4, hands down. Nice. Wow, I wonder how they pulled that off. Must be a really nice engine. Have you ever played, what game I really like the look of? Horizon Zero Dawn. That game looks really beautiful to me. Okay, so once we've chosen our move, and that move has executed, it picked one of these trees, and we got the right command, then we continue down to here, we print off a blank line to separate from separate the other Pokemon's moves from our move, visually. Takes a fat spooky shit on Horizon, and whoa, that's a pretty spooky shit. Then we say, okay, so we did our move, right? Now, if Pokemon 2 is still alive, because our move might have killed them, right? If our move killed them, then we're done. But if they're still alive, they get a turn now. Okay, so the first thing that happens for the opponent's turn is we get a random index. Okay, so an index is a number that you use to get data out of a list. Now, as we know, our Pokemon's moveset is a list of strings, right here. So we're going to get a random index for this list. It's going to be either a 0 to get Tackle, a 1 to get Bubble, a 2 to get Tail Whip, or a 3 to get Tatsumaki Senpuken. Right, so it's going to be a number 0 to 3. So it happens right here. So we use this random randint function. Now, earlier up here, we imported this random library. What that means is that we get all the tools that exist inside that library at our disposal now. Right, so this library called a random, let's go look at it, shall we? Let's go here to our Python documentation. This is at docs.python.org/library. We can go here and we can find random. It's down here somewhere. Numeric values, random. Right? The random library is for generating pseudo-random numbers. And we can see all kinds of cool tools it comes built with. Right? It comes with a thing called seed. It comes with something called get state, set state, get rand bits, all kinds of crazy shit. Rand range. I don't know what all this shit does, but we can read about it here if we wanted to. But what we do have is rand int. Right? Random.randint. So in Python and most other languages like JavaScript and C++ and Java, the period sign is kind of like an apostrophe S in English. It implies ownership, kind of like David's bicycle, right? This is random's randint. So think of the periods that got an apostrophe S, it means ownership. So we're saying random.randint. So this randint belongs to the random library, and it takes two arguments, A and B. It says returns a random integer, n, right, such that A is less than or equal to n, is less than or equal to B. Okay, so what we're saying here, let's go back to our code. What we're saying is, let's go back down here to the Squirtle's turn. We're saying, give us a random integer, somewhere between 0 and 3, including 0 and 3, right? So it can be 0, 1, 2, or 3. And so yeah, it's a function, right? So just like print or input or str, right? It's just a little simple function, or like our deal image function, but it belongs to the random library, so we're using random.randint to access it. What time's the RuneScape event? I have an edit to start. Just want to make sure I'm here. It'll be what, in about an hour and a half? No, closer to 2 hours away, Austin. About 2 hours away. We'll have some time to get ready. Okay, so then we're saying, for our purposes for Squirtle, right? He doesn't take input from the user. He doesn't use the input function to get text from the user. He chooses his own move, right? However, we're saying inputted text, right? We used inputted text up here to get some input from the user, right? But for Squirtle's inputted text, we're just using his move list at a random index. Yo, thanks for the sub, Nebulosa. Holy shit, dude. I appreciate that. If you guys are not aware already, if you have Amazon Prime or Twitch Prime, the same thing, you get a free sub every month. I appreciate using it here, Nebulosa. Yeah, I really appreciate that. That goes a long way, trust me, more than you realize. But in this case, we take the Pokemon's move list and we use our random integer to access some of its data. Right? We kind of covered this very briefly last episode. Let me review it for you guys real quick. So, as of the last episode, we learned a new kind of data. We before only used, my number. We used some integers, right? We had like numbers like 18. We also had, my string. We had strings, right? Like, David, right? Or, flamethrower. We also had booleans. So, it could be like, my bool is equal to, true. Right, or my bool is equal to false. So booleans are always either true or false. When you have a condition, it evaluates to a boolean. You can say, if my num is greater than 15, right? We know that my num is 18, right? That means this is going to evaluate to true. This is a boolean statement, basically, right? So my bool becomes a boolean. It comes out as true, right? Before we only had those three kinds of data, but now we have lists. Right, as of the last episode. Let's talk about lists real quick again. So we also have this thing called a list, right? It can, be like, let's just call it color list, right? And we're going to say, first we start a list with a square bracket, right? And it ends with a square bracket as well. Excuse me. I can't type for shit. There you go. And we can say that it contains, blue. I could just have one piece of data, or, you can use the list like it's intended and put in more than one piece of data with commas. Red, yellow, right? Blue, red, and yellow is our color list. And then we can actually access that data using what we call indexes, which are integers, right? So we're going to print color list, 0, right? So you can take the name of the list, color list, and then you put some square brackets, and between the square brackets put a number. And that number is what we call an index. So what we're saying here is print off the 0th item in color list, which is blue, right? Because they always start at 0. This is 0, this is 1, this is 2. 0, 1, 2. Right, let's demonstrate this real quick. Run the module. See, okay, so it prints off blue. Right, printed off blue right there. But we can say, let's put in index 1 instead. What's that going to be, do you think, guys? Well, that's going to be, let's actually run this here. Probably red, you would think, right? Okay, good, it's red. And we put in 2 would be yellow. Right, so you can put in a number there, which is the index. Now, here we have our PokemonMove list, and we're giving it a random index for our input. So that means we're picking a random item from this list, and then we're comparing it to our move list, right? So we're saying, hey, listen, give me a random number, between 0 and 3. We get a random move. It might be, if it were 0, we get tackle, right? If it were 1, we'd get bubble. And then we say, if it's this, then do that. So it's kind of like AI, right? Now, I played Pokemon Yellow kind of recently on stream, and it seems like that's how they pick their moves for the most part. I think gym leaders are different, but in most random encounters, they pick their move randomly. So it's kind of accurate. Nebulous says, I'll get addicted here. It's my programmer period. I got into web programming, web developing, but I am a guitarist. Oh, nice, dude. A musician. I really love music. I'm a musician, too. Carbonite says, yeah, Venka only codes on Fridays, but I've been here for the last 3 Fridays. Yeah, I actually I'm a gameplay streamer. I stream gameplay almost 40 hours a week, but on Fridays, we do programming here. So don't get discouraged if you see me playing, Mega Man Legends or, Street Fighter 3 Third Strike. I actually program on Fridays here. Okay, I'm sorry, guys. So we have this move we picked at random from our list, using the index, the random index we made. And then we just do the same thing we do with Squirtle, right? We say, hey, listen, is it tackle? Do this. Is it bubble? Then do that, right? As you can see here, bubble's pretty complex because it's super effective against fire, right? But if their type is grass, then it's not very effective. If it's neither one, then it does regular damage. Right? It's kind of confusing here. Python, it's so fast, but powerful too. It seems so I want to know more. Yeah, Python is very quick, very, very powerful, and it's a beautiful language too. None of these, there's no, curly brackets floating around or semicolons ending lines. Everything's all indented nicely in Python. I think it's a really lovely language, personally. I'm a huge fan of it. Okay, so basically the same thing we did here with Cyndaquil, but instead of using our inputted text, we replaced that with a random string from our list of strings, right? Our list of move strings. Okay, very simple. Now there's a bug here, we mentioned this before, right? So just like with Cyndaquil, if the move has no PP, right, then we continue to the top. Now, that makes sense for Cyndaquil, because that just means, hey, listen, you entered the wrong move. Ask them again what move they want, right? Let's say you entered tackle, there's no PP left. Says, listen, dude, there's no more tackles left, so pick something else. Right, pretty basic. However, this bug down here is because if we pick a random move that has no more uses left, it continues, which means it goes back to the top of the loop, which means that Cyndaquil gets another turn. So basically, if we punch in the wrong move, we get another try. But if Squirtle uses the wrong move, then his turn gets skipped. That's a bug. We have to fix that later. Right, it's kind of a drag. But otherwise, very simple, very similar to Cyndaquil's move. And then boom, we're done, right? This is all unindented here. That means that this is the end of the loop. So it goes right back to the top. So basically, we get a turn, right? And then, if Squirtle is still alive, he gets a turn, which is randomized. And then we go back to the top, because it's a loop, right? The loop's right back to the top. We're in this while loop. And then every time you do another loop through, then the condition is reevaluated, right? So we loop back to the top, we ask, hey, listen, are both Pokemon still above 0 HP? And if so, we start over again. And it goes right back to the bottom again, and then it loops back to the top right here, boom, goes right back to the top. Are both Pokemon still alive? If they are, do it again. It's kind of like an RPG, right? Kind of like Final Fantasy or Pokemon. Just keeps on taking turns until somebody dies. Once somebody dies, this is no longer true, right? And once it's no longer true, it stops looping. Once it stops looping, we go back to the very bottom of the loop, and we finally continue down here, where the indenting stops, right? We finally get down to the bottom here. We break out of this loop. Now we say, okay, which one of you guys died? Because we know, because the loop ended finally, one of you guys died. Right? This became false, so one of you guys is dead. But which one is it? We say, well, if Squirtle's HP is less than or equal to 0, so if he's got 0 or lower health, we print off Squirtle has fainted, Cyndaquil wins. right? We say otherwise, right? If Squirtle is still alive, we know he won, because we know one of them died, right? So if Squirtle's still alive, we know that Cyndaquil is the one that fainted. We print off, Cyndaquil has fainted. Squirtle wins. Then we print off a blank line, and then game over. Okay, guys, wow, that was quite a review, right? Took longer than I expected. But now we're finally getting some new material. Okay, so all this code here, it's pretty simple for an experienced programmer, but it is also kind of complex, right? It's 300-ish lines, about 280 some lines, I think. And it repeats a lot of code. Like, all these moves look very similar, right? We have this question at first. We ask if they have PP left, right? Then we do some damage. We print off a message. It's always the same. It's a different message each time. We always print off a message. Then we do some calculation for damage. Then we print off how much damage we did, right? It's very similar each time, and it gets repeated a lot. Furthermore, it's kind of sloppy that we have all these loose attributes up here, right? Like the Pokemon's name and type and HP. It'd be cool if there's a way that we could group all this stuff logically. Right? How are we going to group all this stuff logically so that Cyndaquil is his own conceptual object, right? Let's make Cyndaquil a thing, right? Not just a bunch of floating attributes, but he's a thing now. It's a conceptual challenge. Well, today we're learning about classes, guys. That's exactly what classes are for. Classes are ways we can make our own data types. So we've used strings, we've used integers, we've used lists, but we can make our own data types, such as a Pokemon, for instance. Right? Let's actually go do that right now. So we're going to make a new, we're going to start from scratch here, guys. We're going to redo our code from last time, but in a brand new way. We're going to approach it from a different perspective. Let's use classes. Let's import random right off the bat. We're going to need that for, getting random numbers for our AI, right? But now let's define a class, our first ever class, right? Let's just say class. That's how you make a new class. We're going to call it a Pokemon. Right? Now in Python, it's traditional that you name all of your variables. I'm going to demonstrate this with lowercase letters, and then you use underscores to separate words. That's traditional in Python, and that's true of functions as well. Lowercase letters and then underscores to separate words. But when you do classes, you start with an uppercase letter always, and you can use you separate words by using other caps. We can say like my Pokemon, right? So you don't use an underscore for different words. You use capitalization to separate words, right? So in this case, we're going to just call it Pokemon, and use a colon. It's kind of like a defining a function. We're trying a class. Now inside of this class, we can define attributes, hypothetically speaking, right? We can just say, let's call this Bulbasaur. Right? We're gonna make a Bulbasaur object. Right? So we have this thing called Bulbasaur, and we're gonna give him, how about like a nickname? It'll just be Bulbasaur. Very simple. And you could have like, an element type, and that'll be grass. And he can always have, let's say that he always has, maximum HP. He always has, like, 50 max HP. Then he has attack power. Let's call it attack. And we're going to give him, like 6 attack or whatever. He's got defense. We'll give him 2 defense. And, I think that's what our other Pokemon have, right? Let's go double check this against our old code. So they have HP, defense, and attack. And then they have PP for their moves, right? Let's not worry about that right now. Okay, so now we have this thing called Bulbasaur. Right? Let's actually make use of it. So let's make our short little example piece of code here. Let's say, my Bulbasaur equals Bulbasaur. Okay, so when you use a class you made, you simply assign, and you used your class name followed by, parentheses. That means initialize a new object. It's a Bulbasaur. So if you have this, you're referring to the class Bulbasaur, right? I'm saying, this class, my Bulbasaur, is the same thing as the other Bulbasaur class. But if you put in the parentheses, you're saying use a new Bulbasaur object, make a new Bulbasaur. Right? So here we have Bulbasaur. Now can we print off Bulbasaur's HP? Or his attack power? Let's do that. What's up, Klaus? What's up, Eric? How you doing, dude? Let's run this code, see if it works. There, okay. So we have 6 printed off, right? So here's what happened, guys. We made our own Bulbasaur object, and Bulbasaur has these attributes they're called, right? So previously we called them variables. right? So let's actually demonstrate that real quick. I'm going to actually hide this. So these are variables, right? Pokemon 1 name, Pokemon 1 type, Pokemon 1 HP, right? They're just variables. We have this little equal sign here. We assign some data to them. It's very simple and very fun. But classes have attributes, which are the same exact thing, right? They are variables. They're technically the same thing as a variable. However, they're attached to Bulbasaur, right? They're not just variables. They are attributes of Bulbasaur. They're attached to him, or to that class in this case. So we can use our period symbol here as an apostrophe S. Remember that? It means ownership. So we're saying, hey, we made this Bulbasaur. He's called my Bulbasaur, right? We made a new Bulbasaur. And we can print off his attack power. That's his attack power, right? It's not just, in this case, over here, we just used a name. Right? We called everything Pokemon 1 name, and Pokemon 2 name. And that was just a bunch of loose variables that we kind of grouped together by naming them a certain thing. We usually started their names or their attributes with Pokemon 1 or Pokemon 2. But in this case, actually inside the code itself, there is this thing that is a Bulbasaur, and it has attack power, right? It has attack. Okay, that's really useful for organizing data. In fact, not only can classes have attributes or their own variables, they can have their own functions as well. So we can say, let's define a function inside of Bulbasaur. See how it's indented in there? It actually belongs to this class. We can define what we call a method, which is a function that belongs to a class. We're going to define something called, dance, right? Okay, we're going to have dance print off, Bulbasaur is doing a dance. Right, a very simple function. All it does is print off a message here. Let's utilize that, right? Let's actually run a function. But we're going to say my Bulbasaur dot dance. So now we have this object, which is a Bulbasaur. We made this thing called a Bulbasaur, right? Now this is a Bulbasaur, and it has this method, we call it, right? That means it's a function attached to Bulbasaur. So we can run it. We can say my Bulbasaur, just run my Bulbasaur's dance function, or his method. Let's run that and see what happens. Well, shit, see, Bulbasaur's doing a dance. Okay. So we haven't gotten to what makes this powerful yet, but we're talking about the very basic ideas of defining classes. So what we know is that we can attach variables, calling them attributes, to a class, and we can attach functions, we call methods, to a class, right? We can run them by using this period symbol here. And that really helps organize your code more than you would think. What's up, Sweezy? How you doing, dude? Okay, so let's talk about dance real quick. As you can see here, there's a difference between this and most of our functions. It has an argument, but that argument is self. Now, when you define a method, right, which is to say you define a function that's a part of a class, it must take at least one argument, right? Now, we know from our other code over here, on our last episode, that when you define a function, you can feed it as many arguments as you want, right? That's the data that goes into it. They're separated by commas. And then once you've defined these arguments, you can use them inside your code. So whatever gets fed into deal damage into this third slot, we can use it right here, right? That's what we've learned. However, when you can define a function that has only 0 arguments, right? Like let's do that right now. Let's define a function. So it's called say hi. It has 0 arguments. It doesn't take any data. It doesn't need any data. All it does is print off hello. Right? It doesn't need any data for that, right? So why even give it any arguments? We can use it down here, no problem. Let's just say hi. So run this code here. Boom, so it just says hello. It doesn't need any arguments, right? Why feed it any data? All it does is print off a message. Who cares? But when you're using a method, right, this dance method here, it always is fed one argument, which is itself, right? Because now we have this object, this abstraction, this thing in space that is a Bulbasaur, and it has data attached to it. And we're assuming that if we're attaching functions to Bulbasaur, then it probably needs to know who Bulbasaur is, right? Otherwise, just make a function, right? Why would you even bother making dance? Like, we could actually just make dance down here, right? We could say, def dance, right? With no arguments, we could print off Bulbasaur's doing a dance, right? So it doesn't need any data, right? It does not need any data. However, we're assuming that if we're making a method of an object, of a class, then it must need the data from that class. Otherwise, why would it not just be a regular function? So let's change our code here to be more useful, right? More like a method would be. Usually a method will use the object's data in some way. So let's say, we can say print, let's actually call this print, let's call this print, tell me, how about, says it's, or how about reports its HP, right? Reports its HP, right? And we're feeding in one argument. It always takes one argument, right? Which is self. Right? So now we have this self thing, and self represents the Bulbasaur in question, right? So we can say print. We'll say HP string is equal to the string version of self dot max HP. Okay. Then we can say print off. Bulbasaur says I have plus HP string plus health. Okay. Let's talk about this code before we run it, right? Before we run it, let's talk about it a little bit. So we established that functions, loose functions, don't need any arguments, right? Because, for instance, this little print statement here, this print doesn't need data, right? It just does its thing. It does what it does. It doesn't need any, supplied data in there. However, a method of a class is assumed it's probably going to need to know some of its own attributes, right, to work. Because if it didn't need its own attributes, why even put it inside the class, right? It should all be organized together because it's all related to one another, right? All these attributes and all these methods, they all relate to this Bulbasaur in some way. That's why they're all together. So for that reason, you have to supply itself as the first argument, right? So first thing we do here is we get its HP and we turn it into a string so we can print it off, right? We're using self right here. We fed in self, and now we're using self right here. We're saying, hey, listen, I want to know myself, apostrophe S, myself's max HP, right? So we have a reference to our own object, and we're getting its max HP attribute. Then we're using that data to print off some customized string. All right, let's try that. Let's get rid of all these pointless functions up here. We don't need any more. There's examples. Let's use, my Bulbasaur dot reports its HP, right? And as you can see here, when I use the function, I don't need to put in self right here. I don't need to put that in there because it's implied inside of a method. So it appears that there's no arguments, right? There's no arguments here. But because we have this apostrophe S, we know that the first argument is this thing, my Bulbasaur. Whenever you see an apostrophe S and then a method, that means that the first argument is this thing, my Bulbasaur. So it gets fed in right there. It gets itself. Let's run this code. Okay, so Bulbasaur says, I have 50 health. Now, if we had a different Bulbasaur, we could actually have it change. Let's actually do that right now, in fact. Let's actually change his health. I'm going to show you guys how that works. Let's go, Dix. Welcome aboard, dude. Glad you're enjoying the show, Sweezy. We got a Prime sub, yeah. Our friend Nebulosa gave us a Prime sub. I appreciate that. Let's now change that attribute. Okay, watch this. We're going to say my Bulbasaur dot max HP equals 45. So we can actually define attributes, right? So in this case, we gave him like a default attribute. Right? As soon as we make a Bulbasaur, he gets this attribute, right? But we can actually change that value right here, just like any other variable. Right? We just have to use the apostrophe S. So we're saying, listen, we're assigning my Bulbasaur's, apostrophe S, max HP. Now it's 45. Now report your HP again, bro. My Bulbasaur dot reports its HP. So we're running this method, right? It's attached to this Bulbasaur. Let's see what happens now. Okay, so in the first section, it says I have 50 health. And then we change his health and had him report it again. Now it says I have 45 health. So maybe you can see, maybe it's still too abstract for you guys if you're totally beginners. Maybe you can see how having the attributes and the methods all attached to each other can be very powerful. Right, now let's use a more practical example. Right, we've been kind of goofing off and talking about the very basics of classes. let's actually do something a little bit more interesting. Right? So let's redo our code from scratch. So let's make first of all, instead of making a Bulbasaur, let's make a Pokemon instead. All right, we're gonna make a Pokemon. All right, so this is any kind of Pokemon, not just a Bulbasaur. Let's get rid of all this code down here too. So what does a Pokemon have? Well, it's got, according to our code over here, it's got a name, right? A certain Pokemon type, and it's got. Let's give it like a Pokemon type, right? So it's got like a monster type, right? In this case, we don't know what it is yet, right? Let's just call it none. We don't know what the monster type is yet, but we know it's got one. And then it's got this amount of HP, right? So we're gonna say like max HP equals we don't know what it is yet, right? Let's just say that it's none, right? For now, we don't know what it is yet. Then we can say it's got some attack power. That's none. Oh, I just realized something, guys. We should actually talk about init before we do this. So I'm actually gonna delete all this. So previously we talked about how we can define attributes by having data here, right? We can say like a monster type is Bulbasaur, hypothetically speaking, right? Then we could say my Pokemon equals it's a Pokemon. Then we can say print off my Pokemon's monster type, right? This will give us a Bulbasaur. We know that, right? Let's try that. There you go. So I got Bulbasaur. Right. Cool. Awesome. Basic. Because we define this attribute. So Faust says, by the way, Venka, I'm planning on streaming the event at the same time as you. Figured it might be fun to have a co-host. Let's go, dude. Let's go, Faust. Okay, but let's talk about special functions now, guys. Functions that, special methods that are always a part of a class, whether you define them or not. So let's talk about init. Right. Let's talk about what this means here. Next week's event, I haven't decided yet, Dix. I'm thinking maybe pizza and cartoons. We have a backlog of events to go through here. It could be pizza or cartoons. It could be Mario Aces. We could do Mario Aces next week, if it would please us. There's a few things we've actually got funded on the stream here. All right, so we have this init method, right? So we talked about defining functions inside of classes before, right? We learned that it's a method, and the methods always take at least self, right? Because that way they can access their own attributes. But we haven't talked much about the difference between a class and an instance. Okay, let's talk about that very briefly here. So a class is like, it represents all the attributes and functions, methods that are a part of that type of thing. So we had Bulbasaur, he had this, that dance method, remember that? That was a method that, is a part of that class. We know that, right? And we know that he had, amount of max HP and attack power and defense. That was all a part of his class. However, different Bulbasaurs, just like in the actual game Pokemon, can have different stats, right? They can have different amounts of HP, depending on their level. They can have different amounts of, attack power and stuff like that. They can have different moves and stuff. Even though they're all the same kind of thing, they're all the same Bulbasaur, they're all Bulbasaurs, but they're not, they have differences between them, right? Now, in programming, we call that a class, which might be a Bulbasaur, right? That means that all the Bulbasaurs are part of the Bulbasaur class. But each Bulbasaur can have its own attributes, and those belong to the instance. When we say an instance, we mean that particular Bulbasaur. Right? So in this case, we have these Pokemon, right? Now, a Pokemon is a class. Every kind of Pokemon is a Pokemon, but each Pokemon is different. So they really have a lot of instance attributes, which is to say, they have these attributes, but they're not shared among all Pokemon. They're just for that one Pokemon. Right? See what I'm saying here? So when you assign to self, like, self dot, that's apostrophe S there, self's monster type, you're not really talking about every Pokemon. You're talking about this certain Pokemon, right? Because self refers to itself, whatever this Pokemon is. So what's really cool about the init function every class has an init function. It starts off and ends with 2 underscores. That means it's a special function in Python. It means that whenever you make a new Pokemon, this code runs, right? In fact, why don't we actually print off a message here? Print off, we made a new Pokemon, right? Let's run this code now. Okay, so we get off a message here right away. It says, we made a new Pokemon, and then we get Bulbasaur. Right, so what happens here is this code right here, my Pokemon equals Pokemon, and then we do this, this little parentheses here. Before I explain, these parentheses were referring to the fact that you're making a new Pokemon, right? So if we said my Pokemon equals Pokemon, like that, we're saying that we're making a new class, right? We're referring to the Pokemon class, and we're making a new class that's equal to Pokemon, right? So we have 2 classes now, my Pokemon and Pokemon. However, when we put in these quotation marks, we're saying make a new instance of my Pokemon, right? Spawn a new Pokemon, spawn something, spawn a new object that has the features of this class, right? We're not talking about the class anymore. We're talking about a new instance, right? We're making a new Pokemon, a new one of these things. And we put these parentheses here. You're actually running the init function, right? And again, it has these underscores here, which mean that it's kind of magical in Python. That means it's a special function. It's you don't really see it work, but it's working behind the scenes, right? So in this case, even though we're running this thing, Pokemon, we have the name of the class, we're actually running the init of that class, right? And every programming language has a similar situation for this. And when we do that, we run this method, this function, and it prints off this message here, and then it gives ourself a new attribute, monster type, Bulbasaur, right? So we make this new one here, it prints off the message here, gives us an attribute, and then we print off that attribute right here. Okay, so why is that powerful? Well, here's why. Because, goddammit, you can feed in arguments into a init. So why don't we say, monster type is an argument now. And now we can say our monster type is whatever was fed in there. So, self.monsterType, right? We're making a new attribute, is whatever was fed in. So now we can say Pokemon is a Cyndaquil. I'm not even sure how to spell that. Is that how you spell Cyndaquil? So now when we define a new Pokemon, we can give it arguments to define that Pokemon. Pretty fucking slick. All right, let's run this code now. There, it says Cyndaquil. Okay. So what's really cool is that we have all these, over here in our last example, we have all these variables, right? They're repeated. They're all the same variable, but they have different numbers, different names, different words, right? But they're all the same ideas. Well, that's exactly what classes are for. They're for grouping ideas together, things that are similar, things that are repeating a lot. We can actually save a lot of space and kind of logically sort things, organize them for our own convenience as programmers using classes. So why don't we do that right away? Let's make a thing called a Pokemon, right? A Pokemon class, and give it some arguments, right? We have a monster type. We've got some amount of maximum HP, right? Let's just call it, let's call it HP for now. We'll actually talk about maximums later. It's got some amount of attack power, right? It's got some amount of defense. Okay, let's go back to our code here. Okay, what else does it have? It's got PP for all of its moves, right? Let's actually not fuck with that right now. No, let's do that. Let's just do it, right? We'll do the same way we did before. So it has, it's got move 1 PP, right? They have move 2. They have 4 moves, right? It's got move 3 PP, and it's got move 4 PP. And then it has, a move list, right? That's everything that Pokemon has so far. And this is a pretty long line of code, guys. Let's actually break that line, so we can have it a little bit easier to read, right? There you go. What number? What line? This is what character number? Okay. Boom. So we broke this line here to make it a little bit more easy to read. That's kind of has a lot of arguments here, right? And we're gonna assign all this shit. Let's assign all this shit now. So we have all these arguments in a init, right? Let's actually make them a part of our Pokemon. So we're gonna say, hey, self.monsterType is whatever they fed in as the monster type. Self.HP is whatever they fed in as the HP. Self.attack is whatever they fed in as the attack. Self.defense is whatever they fed in as the defense. Self.move1 PP is whatever they fed in as move1 PP. You guys get the idea, right? Self.move2 PP is whatever they fit in as move2 PP. Self.move3 PP is whatever they fit in here. Let's talk about this in a minute here, why I'm doing this. And self.move4 PP is whatever they fit in as move4 PP. And they also have a move list, right? Okay, so why did I do all that? Why are we just repeating all this shit over and over again? Well, here's why, guys. Because as you guys know, functions, let's talk about functions again. Go back here. Functions take data in as arguments, right? And they cannot use any data, basically, that wasn't fed to them as an argument, or wasn't defined previously as a what we call a global, right? So you want to feed in data to them as arguments, and then to get data out, you have to return that data. That's the only way to get it out, right? There's no other way to get data out of a function, except by changing what we call mutable objects, right? So we can, in functions, we can return data, but we can change objects too. We can change things in that function. So we can actually, alter stuff. So here's what we're doing, guys. We want to save all of these attributes we fed in, right? But these are just arguments. So when the function's over, then they vanish, right? We're not returning anything. We can't just say, return whatever. We're not returning any data. So how do we save this data? Well, we're saving the data by altering an object. We're altering something as a way to save the data. In this case, we're altering ourself, right? So we're taking this data here that came in, and we're saving it by attaching it to ourselves as attributes. At first they were arguments. Now we're attaching them to ourselves as attributes. Cool beans, those. So now we can actually define both Syndidix or Cyndaquil and Bulbasaur, and Squirtle a lot easier. Let's actually refer to our old code and copy it exactly. So, we forgot the type. We gotta give him a type, right? Let's do that. Excuse me, I'm stupid. He has a monster type. He has an elemental type too. Okay, so let's actually break these lines again so it's not too long. There we go. Okay. And we're going to assign that right here. The order is not important. I'm just doing it to make it more easy to read. You can do it any order you want. I'm trying to do it in the same order as they get entered in here as arguments for no reason except to make it pretty. Okay. Yeah, if you guys can't make it to RuneScape, I had no hard feelings. I totally understand. Dick says, I think I'm going to try and make it. Depends on if I can hash out my last bit of work in time. Yeah, if you guys are feeling sick, if you guys aren't up for it, totally understand. I know it can be quite a grind. Okay, so now we have this thing called My Pokemon, right? Let's try and just run this, and we're going to get an error message, and you're going to see why. All right? We're going to try and define a Pokemon with no arguments, right? But just like any other function, right? Just like any other function, if you define arguments, it has to have them. So we're going to run this code. Let's see what it says. Okay, we got an error message here. It says that we tried to find a Pokemon, but a init, which gets run when we try and do this, is missing 10 required arguments. It doesn't have a monster type or elemental type or HP or attack or defense, none of this stuff, right? It needs all that shit to make a new Pokemon. So let's do it. Let's say, Pokemon 1, as it was called in our old code, is equal to this Pokemon. And he's got a monster type, which is the first argument. We're going to have it be a Cyndaquil. Oh, that's how you spell it, right? Not an I. It's with an A. Or is it? I don't know. And then it's got an elemental type, which is fire. It's got how much HP? I actually put a space there. I missed one. Our old Cyndaquil had how much HP? He has HP, attack, and defense. That would be 55, 8, and 2. All right, he's got 55 attack, 55 HP, 8 attack, and 2 defense. Then he's got PP for all of his moves, right? 1, 2, 3, and 4. What do those look like for him? That's 10, 5, 12, and 8. So let's enter that in here. 10, 5, 12, and 8, right? And then you need the move list. Let's enter that in there. So that would be tackle, what do you have? Flamethrower, tail whip, and growl, right? That's his moves. So let's look at this here. Yeah, tail whip and growl. Okay, so it's going to be a very long line here. Let's actually break this up a little bit. Let's break a line right here. And break a line right here. There you go. Okay, so now we've defined this Pokemon, right? And give it a bunch of arguments. We could have, what, like 10 arguments? So we feed in the monster type as the first argument. Because again, we ignore the first one here. So the first one is actually self, right? But again, self is fed in automatically whenever you have a function, or a method. Skull Crusher says, I guess I just missed it, but what is def-init? Def-init is a magical function that's always run when you make a new object of your class, right? Actually, we'll cover that here again. So actually, let's make this a little bit more simple, huh? Let's make a new class. Right, we're gonna call this, class, basic ass class. Right, very basic fucking class. And we're gonna give it, an attribute called, basic ass attribute. It's gonna be the number 1. That's pretty fucking basic, right? So when we run this, we make an object of this type, right? This basic ass class. We're gonna say, my basic object is equal to basic ass class object, right? Whenever we make a new one of these things, it runs init, right? It always runs init. And if you don't define it, it's whatever, right? It's a pretty basic function. It doesn't need to define it. Whatever the default is fine in this case, right? But if you do define it, you can change the behavior of whenever you make a new object. Let's do that right now. Let's say, def init, just self, doesn't need any other kind of stuff. It's not really a very special init. But we're going to print off a message, we just made a basic ass object. Right? So now whenever we make one of these, this code gets run. So whenever you make an instance of a class, it always runs init. Right? Underscore, underscore, init, underscore, underscore. So let's do that right now, in fact. We're going to run our code. There you go. See, we just made a basic ass object. It's printed off. Now, why is that printed off? Well, because when you do this right here, it always runs init. Right? So here we have init. It has a little print statement. You can use it for diagnostic stuff like this, right? If you want to make sure you know when things got made. In our case, though, we're using init as a way to get arguments. So we have, this basic ass argument. We can say, print, our basic ass argument is, we can add in, the string version of that argument. Right. So now we have this initiator, init right here. But we can give it an argument. We can say, is, bleh, right? So now when we define this class, we can feed it an argument, and it'll get this message come out. Right? So we made a basic ass object. Our basic ass argument is bleh. Bleh. Right? So in this case, we're using init right here to define all of these cool attributes for our Pokemon. We're using all these arguments to attach them as attributes. Can you put BA attribute inside init? So if it gets an argument, it becomes the value of attribute. But if it wasn't defined, it defaults to 1. I'm not sure what you mean by BA attribute. But yeah, we can do that if you want. But let's talk about that more later on. We'll do that right now, though, because you asked. So it's inside init, so if it gets an argument, it becomes the value of attribute. Inside init, it wasn't defined, it defaults to 1. Yeah, you want to do that? Let's do that, I guess. Not totally. Basically, oh, I'm sorry, thank you. Yeah, I got you. Okay, so yeah, let's do that. So we're going to talk about this more later on, guys. This is kind of advanced for us right now. But you can define default values in Python very easily by just having it right here. That's how you do it. So in Python, when you define any kind of argument for a function or for a method or whatever, if you use the equal sign and then a value, that means it becomes optional. Right? That means that if it's not there, just make it this. Right? So we have bleh right now. Let's actually rerun this here. Run module. Okay, so we supplied a bleh, so it says bleh. Right? But if we don't supply anything, what happens, do you think? Well, now we have this default value, it's called, right here. So if we don't supply it, it's no big deal. It has a default value that kind of comes in clutch. All right, let's run this code. There you go. See, so our basic argument is 1. Right? So the default's to 1. Easy. Easy peasy. That's your question there, Skull Crusher? Oh, no problem, Skull Crusher. It's always a pleasure to answer some questions here. In fact, that's a very useful feature. I've just been avoiding it because I'm trying to keep it simple here for the total beginners, right? People that have never programmed before in their lives. I don't want to get too advanced here. We'll talk about default values more in depth later, but they are a very, very useful tool, don't get me wrong. Nebulous, so if you declare it to the default, in the definition itself, tricky, but GG. Last minutes for me. Thank you, Venka, and company. Good stuff, Nebulous. It's a pleasure having you, dude. So we'll be doing this again on next Friday. Carbon says, I guess my question is, the self argument you don't have to supply. Yes, we talked about that a little bit earlier. I'm going to review it, though, for you. Self is an implied argument, because when you have a function, let's make a little function here, def, say hi, right? If you don't need any arguments, don't define them, right? Because say hi, all it does is print hello, right? It doesn't need any data, right? It doesn't take any data in, doesn't get any data out, there's no return value. It's a very simple function, right? I'm going to actually delete all this because I don't want to be confusing you guys. Too much data on screen at once. So we can run say hi, right? It doesn't need any kind of any arguments. It's a very basic function. It does a really simple thing. Let's run it. Okay, there, it says hello, right? It says hello right there. Very, very basic. However, the whole point of classes is to organize your variables as attributes of that, of that object, and to organize your functions as methods of that object. They're the same thing. A method and a function are the same thing, but a method is attached to an object, where a function is just loose and floating in the ether, right? But we're assuming that if you want to attach a function to an object, it stands to reason that you probably want to know some stuff about that object as a part of how that function works, right? So every method always takes the object it's running from as its first argument, right? So if we make a Pokemon, for instance, we have this Pokemon we just made, right? Let's make a method, def, say your type, right? It takes self, right? It always takes self. Every method always takes self. And we're going to say print off, my type is plus self, right? We got self, right? We got this as an argument. We have self now. Self dot elemental type, right? So we're going to run that right now. We defined a Pokemon. It's a Cyndaquil. It's got fire type. We're going to say Pokemon1 dot say your type. There you go. Let's run it. Excuse me, you can run it here now. Okay? So it says here, my type is fire. Right, my type is fire. So just by virtue of, having this apostrophe S here, we know it's attached. We know it's a method, right? As long as we know it's a method, then we know it's getting self. So it's only for exactly Carbon. It's only for referencing that object's attributes or methods, right? Like we can say, how about we do, def say your HP self, and we can print off, my HP is plus, string version of self dot HP, right? So only two methods, but we can also say, let's print off, we're gonna make a new method here called def say everything. So what does this one do? Well, it takes in self. It's a method. It always takes self, right? And then we can print off. Well, we can actually run both methods. We can say self dot say your type and self dot say your HP. So we can access our attributes and our methods, right? Because self is our self. It has all of our attributes and all of our methods attached to it. So we can just say, Pokemon1 now can say everything. Right? It gets itself as an argument. We can use that object to do all kinds of fun stuff. Let's run it. Boom. So there, it says my type is fire, my HP 55, right? Because it knows itself, right? You gotta know thyself. What's up, Zax? It says from time import sleep 1. Yeah, time is a really cool library. We can get cool timing-based functions, and sleep means it's a function that makes the program not run for a certain number of seconds. So I think that's, is that 1 second? I'm pretty sure in Python it's seconds, right? Not milliseconds. What's up, Gunslingers? So is there no concept of scope in Python, thus self is used? No concept of scope. There's scoping. Hell yeah, there's scoping. But I think it's used differently than whatever language you're talking about, whatever language you're referencing. But yeah, scoping is definitely a thing. That's exactly why we have to have this init method here. because these are arguments for this function here. You know, when you define a new object, it runs init. You can feed it arguments, but just like any other function, once this function is over with, all of its variables and stuff that you defined inside that function go away. They're gone, right? Because of scope. But if you save those attributes to an object that is mutable, so self can change, it can mutate, right? Self can always be changing. We can always be adding stuff to it. Because we're changing that stuff, we can get data out, essentially. But yeah, once this function ends, like any function in Python, everything defined inside of it is gone because of scope. Do you need to always put in method self? If you don't and just put method, no skull crusher. It'll actually crash it. Let's try that. It'll crash the program. Watch. So look, we can say here, you know, def, you know, this will crash. No arguments at all. Print off, you know, hey, we didn't crash. Right? If we made it this far, we didn't crash. Yeah, I'm sorry, Gunslinger. Yeah, it's a very different syntax from Java for sure. But yeah, scoping is still definitely a thing. I'm not sure if it's quite as strict as it is in Java, but yeah, that's why we're saving all these attributes here. We have these arguments, right, monster type, but we're saving them as attributes of self, because once this init function is done, everything is gone, right? Thankfully, we have this mutable object, self, which can always be changed. So self makes it out. That's why we're attaching stuff to it, so we can save it for later, because self is going to survive this, but everything else is going to die. All these things on this side are all dead due to scope. Because our beginners might not understand what me and Gunslinger are talking about, it's no big deal. We're talking about kind of a more advanced concept. Okay, so we have this new method here called this will crash, right? It's not gonna, we can't even run it, because as soon as we try and define it, it's going to crash the program. I'll demonstrate. We're going to try and define a method with no arguments. Oh, well, I guess I'm wrong. I guess it didn't need an argument there. Well, I take that back. That's weird. Let's try and run it. This will, maybe it won't crash. Will it not have self? Is that a new thing in Python 3? Oh, okay, it doesn't actually crash. It takes 0 arguments. Oh, okay, well, there's your problem, right? So this will crash takes no arguments, right? It takes 0 arguments, but 1 was given. Because by running it like this, it always feeds in self as the first argument. So we fed it self, but it has no room for self. There's no spot for self to go into. So that's why it crashed. Interesting. I thought it would stop us when we tried to define it. So yeah. Yeah, exactly. I says I got self, right? It's a method, so we always get self. But this method here has no spot for self, so it crashes. Interesting. Okay, well, I didn't know that. I learned something. You can call it as Pokemon this will crash, but yeah, that was the instant. Well, yeah, can we? I think it still gets fed in class. Maybe I'm wrong about that. I guess because we don't have a class. Oh, yeah. So Anderson is right. We can actually call it from the class, not from the instance here. So here we defined a Pokemon, right? We defined a Pokemon. But if we just use it, you know, as the class, you know, this will crash method of the Pokemon class, then it'll work fine. However, it won't have access to some pretty cool stuff. Let me actually run this now. Yeah, so hey, we didn't crash, right? However, if we defined like class attributes, like, you know, let's say every Pokemon, you know, every Pokemon is, you know, it's like 4 foot, you know. Let's say every Pokemon's 4 foot, right? We can't access the Pokemon's height by running it this way. However, we have a thing called class methods later, and a class method actually can use the class's attributes outside of, you know, a init. But yeah, interesting. But typically, though, you usually don't want to define a method without using self. Like Anderson said, you can use like a static method, but that's probably not that great for organization, especially as a beginner. I don't think I want to worry about that too much. They're not using Notepad, Dix. We're using idle now, yeah. Slinger, the reason we're using idle here is because we're beginners here. We're our first day programming, our third day programming here. At first, we used Notepad because we were comfortable with Notepad, right? We're all beginners here. We know what Notepad is, how it works. We've been using that. However, now we're graduating to idle, which comes with Python. That's why we're using it. Because as beginners, we might not know what PyCharm is, so we are just using what comes with Python, which is this program here. Is init what you call a constructor, or is it an initializer? As for the actual, you know, the lingo, I'm not so sure. I think it's some languages call it a constructor. It's also an initializer. I'm not sure if in Python what you call it exactly. But yeah, it constructs the object. I think it's, and back in C++ it was called constructor. But I'm not sure if there's a certain term that's different in Python, to be honest. Yeah, I know in C++ we called them constructors, if I'm not mistaken. But yeah, this is just an initializer. It makes a new object, a new instance object, we should say. Right, an initializer maybe. I'm sorry I couldn't be more precise for you, Skull Crusher. Okay, so now we have this Pokemon, and he has these attributes we made right here when it gets initialized. And it has these methods we don't need anymore. These are just example methods. We're going to actually delete all these. Cool beans. I always hear constructor. Wasn't sure if Python thing was a thing with a knit. Yeah, constructor, yeah, this is what this is. Okay, I'm not sure if Python has a certain term for it, but in every language you have constructors as a part of your class that make the instances. That's what this is here. It's code along, yeah. I'm late to the party. I can watch your previous streams. Yes, you can, Gunslinger. They're on YouTube. That's at youtube.com/VencabotArchive. youtube.com/VencabotArchive, one word. Or just search for Vencabot on YouTube. You'll find all my stuff there. There's all kinds of cool gameplay there, like, you know, classic games and stuff. But there's also playlists there for Python. Intro to Python. All of my past streams are saved there for Python right now. Okay. So, let's, we made this Pokemon thing, right? It's pretty cool. It has all these attributes now. Why don't we create some methods for it? Like, how about tackle, right? Both our Pokemon have tackle, right? Let's just hypothetically, for our example here, let's say every Pokemon has tackle, right? Any Pokemon can tackle you, right? So there's this thing called tackle. And what does it do? Well, it takes itself, it's a method, and it takes whoever you're tackling, right? So let's just say, you know, opponent, right? Cool beans. So how does tackle work? Well, let's go look at it, shall we? Let's actually copy-paste the code. So down here, this is our old code, guys, but it didn't have any classes yet. But down here is where the tackling happens. We say, hey, listen, if the user asked us to tackle, right? If the input text is tackle, then run this code here. This is how tackle happens. Okay. I just realized we have a problem already, but I'm going to fix that in a second. Because we kind of changed the way our code works. Okay, so let's just paste the code for now. Okay, can I do that with, I want to use vim commands, but I don't know. Let's just paste it like this. Okay, so let's unindent this. Okay. Cool. So, yeah, I don't like this. Because we have this move PP thing, right? The PP is attached to the Pokemon. But we don't know, if we have this tackle function, or tackle method, we don't know which of the moves is tackle. What's up, Coder? Welcome aboard, dude. We don't know which PP to subtract from, right? Is tackle our move 1? Is it our move 2? Is it our move 3? We don't know. How are we going to solve this problem? Well, let's just assume for now that tackle's always move 1. Right, we're going to fix this later, guys, I promise. But for the sake of education, I don't want to get you guys too advanced too quick. We're going to assume that tackle is always move 1. I just made celery task worker. I'm trying to understand HC coder. You have to explain that to me here. So we have self, we have the opponents, right? We're going to say if self dot move 1 PP is 0. So if we're out of PP for move 1, which we're assuming is tackle in this case, we're going to print off the tackle has no remaining 8 PP. Right, done. This code is done now. So we're going to return. Now, as you guys know, when you return from a function, it brings data back. It gets data out of the function, but also has a side effect of ending the function right away. So we're not going to return any data here at all, but we are going to say end the function, right? Return out of here. We're done. We're out. No PP left. We're done. Get out. But if it's does have PP left, we're going to say, listen, we'll print off our name, right? So self dot in this case we'll call it the monster type. That'd be Bulbasaur or whatever, or Cyndaquil. And he tackled our opponent, right? Now, here's the cool thing. Unlike before, where we had to feed in like a loose variable, like we had to feed in like, Pokemon2 underscore, name. Now we know the opponent. We know a lot of stuff about this guy, right? Because now we know his opponent, he's a Pokemon. He has all these attributes. Well, that's sick, right? It saves us a lot of space in our arguments. Because now we know it has a monster type. we can say opponent dot monster type. All right, so we know that we got this opponent object, but this object comes bundled with a lot of data now that we can actually utilize very effectively. What's up, mutant? Where do you live, Coder? HZ Coder wants to move to the USA, huh? Okay, so we have this opponent object. It's a Pokemon, so we know it has a name. So we can print that off here if we want to. I'm actually going to break some lines here, make it a little more readable. There you go. And we know that we can calculate damage now, right? So we have our Pokemon's attack power. So we're going to say this is now going to be self dot attack power, right? Minus our opponent's. Excuse me, I'm typing like shit. Our opponent's defense. Because now we have this opponent that we're feeding in, and we can access all of its attributes. So that's very powerful, right? It's very simple, very powerful. And that's why you code using classes. Thank you for the follow, Skull Crusher. And what is this? Stigister? I'm sorry if I misread that. Thank you for the follows, guys. We stream Python development here on Fridays. We're actually like a gameplay stream, lots of Street Fighter here, lots of retro games and modern games. But on Fridays, we kind of do like programming tutorials. Bookmark board. Hopefully see you guys next Friday as well. Thank you for the follow, Mr. Anderson. Mr. Anderson. USA, more like you suck, eh? Wow, dicks. That hurts me. That cuts me deep. Okay, so now we can change that Pokemon's health, right? So now we can say opponent. Thank you for the follow, Skull Crusher again. 1, 2, 3, 4. Opponent.HP is equal to. Oh, we don't have this deal damage function. That's fine. We don't need this deal damage function for now. Let's just ignore that and write our own code here. So we're going to say it's equal to. Let's first of all make sure the damage is actually a positive number. So if actual damage is lower than 0, it's a negative number. You're going to heal your opponent, right? Let's actually make sure we don't heal him. So if the damage is less than 0, make sure that it's 0. That way the number is always positive or 0. And then we can print off some messages here about how much damage we did. So we can change the HP here. So the HP is going to be equal to whatever it was minus the damage. Right. Opponent HP minus the damage we wanted to do. Right. So if we found out that we did, let's say we did 5 damage, their HP was 10, we're saying, hey, listen, they had 10, subtract 5, that's their new HP. Okay, let's print off some messages for the user here to make it easier for the player. Let's print off, self.monsterType plus, let's just say, let's actually say the opponent here. Opponent.monsterType plus took plus the string version of our damage plus damage. So we can print off how much damage we did for the user. I'm going to actually break this line here and make it a bit easier to read. I don't want to have to do a lot of scrolling if I can help it. Cool. But I'm missing the chat here. Just got to learn how to eat ass and you can live like a king. Is that true? I should learn how to eat ass, huh? Oh, did I miss Mr. Mutant, huh? What did Mutant say? See if I can find that here. Which one do you prefer? Prefer of what? Oh, colors. Okay. Gotta hide that thick. That's funny. Gotta move to the US for work, huh, Dix? Why is that? You wanna work here in the US? Canada's kind of nice. Okay, we print off how much damage we took. Let's print off how much HP he has remaining, huh? Let's print off, opponent.monsterType plus has plus string opponent.HP, whatever their HP is, plus HP remaining. There you go. Let's break this again so it's not as deeply indented. It's deeply scrolling, I should say. I don't want to scroll too far off the screen. There we go. I need high-speed internet, house, and a car. Yeah, here in the USA, high-speed internet is pretty much the standard now, which is kind of nice. Okay, now we're going to remove, we're going to lower our PP here for this tackle. So we're going to say self.move1pp is self.move1pp minus 1. We're going to print off how much PP is left. We're assuming that's our first move, always. There we go. I missed copy pasting this thing here. Okay, sorry guys. A little bit of a tangent there. Let's examine what we just did. Or what did we just accomplish there, do you think? Well, what we did was we have this new tackle method. It's a part of a Pokemon. Every Pokemon can tackle, and for our purposes right now, tackle is always move number 1. Right? So first thing we do is when we run tackle, we make sure we have some tackles. Right? If we have some tackles, then we run all this code here. But if we don't, we stop right here. Right? It says if self.move1pp is equal to 0, so if we're out of ammo, then we print off, tackle has no remaining PP. Then we return. The function's over with. We return. It's over. But if we made it down to this part, we know that we have some PP left. We didn't return after all. We print a message here real quick. The message here is just some text saying that, our Pokemon tackled their Pokemon. Then we do some calculations here for the damage. For tackle, very simple for our purposes, right? We just take our attack power, self.attack, that's our attack attribute, and we subtract the opponent's defense. Now, how do we know their defense? Because we have the opponent. We have the entire opponent here. Right? We know their defense, we know their HP, we know their name, we know all kinds of fun stuff about them. So now we have a lot of power in this one function. Very simple. And this one little argument here has a lot of data for us. Make sure the damage is positive. Right? I don't want to have negative damage that'll actually heal the opponent. And then we actually reduce the opponent's health by that damage. Right? Let's say that I did 10 HP to you. Now your HP is 10 less than what it was. Right? So that's what that is right there. Then we print off some more data for the user. This is just for the player's benefit. Just tells them what happened. Right? It tells them how much damage the opponent took and how much health they have remaining. Gunslinger says, I subbed to your YouTube channel. Will you make a game tutorial? Yes, Gunslinger, I certainly will. If that would please you guys, by all means. As long as you guys keep coming here on Fridays, I'll keep on making the content escalate, or we can go back to the beginner stuff if you guys want. And I'm just a puppet dancing on a string for you guys. Whatever pleases you guys, let me know. Let me know on Discord at Vencabot.com. Let me know on my YouTube comments. Let me know here in the chat, and we can do what you guys want to do. Okay, so then after we've printed off that data for the user, we subtract the ammo, which is called PP in Pokemon. Right? We're saying, hey, listen, whatever our PP was before, now it's 1 less, because we used to move 1 time. Right? So we've used up one of our things. Dance, Puppet Man, dance. And then again, we print off some data for the user, how much PP is remaining. Right? Very simple. And there you go. Now we have this tackle thing. Well, that's kind of fucking sick, right? I mean, we just made it. It's pretty straightforward, except for all this indenting here. Again, in Python, we have what we call hanging indents, right? Which means that if you can't fit it on one line, you indent it down, indent it 4 more spaces, and then you kind of keep on breaking the line that way. That way you don't have to keep scrolling to the right. However, if you're not careful with your long variable names, like me, I like really long variable names here, like opponent.monster type, you can break over multiple lines. It'd be kind of ugly sometimes, I apologize. Like that. See that kind of weird indent in here? All this means is I'm just breaking the line. Don't want to have it all be scrolling that way. If you guys wanted to, we could just do it, like this, and have it be on, one line, but you have to scroll this way. Kind of sucks. So I'm going to break some lines here. And then do that again here. Okay. So, let's run this code now. So cool, we have this one Pokemon, right? It's Cyndaquil. Let's make our other Pokemon, right? From our old code. That's going to be, another Pokemon. This one's going to be, let's do it on one line for now. It's going to be a Squirtle, right? Now, if you guys have been watching our stream for the past few weeks, you guys know that we kind of did some very basic examples of making a Pokemon game without using classes. Today is our first day using classes. We're kind of converting our old code to a new system. But here's our old code. The old code had no classes, and it worked really well. But we're going to try and clean it up today. In this case, we have the second Pokemon, who's a Squirtle. Now, he's a water type. Let's go fill that in right now. All right, so he's a water type. As you can see here, guys, his elemental type is his second argument, not including self. So Zan says he's doing these things once a week. It'll take a long time unless he plans on making it a more I do plan on making a more regular thing, Zanzi, for sure. The median annual salary for doctors is 80,000 USD in Sweden. Kind of rip. Is rip a good thing? Good stuff, mutant. Learning about programming. What's up, Mill? CJ? You can buy a really nice house and a really nice car for 1 million, Coder. 1 million's a lot of money in US dollars. Okay, let's make a second Pokemon. Right? He's Squirtle, he's water type, and then we have what? HP, attack, and defense, right? So what are those numbers for Squirtle here? He's got 68 HP, 6, and 4. All right, let's do that. So we got 68, 6, and 4. Did I just do that wrong? No, I didn't do it wrong. Okay, so he's got, then he has PP, right? He has 10, 6, 12, and 666 PP. Let's do that. 10, 6, 12, and 666 Tatsumaki Senpukens. And speaking of Tatsumakis, we gotta get his move list now. So what's his move list look like? His move list is Tackle, Bubble, Tail Whip, and Tatsumaki Senpuken. Let's do that. Okay, so he's got Tackle, he's got Bubble, he's got Tail Whip, and he's got Tatsumaki Senpuken. Okay, cool. We can put our closing parenthesis on there. That's our entire init function there. But let's break this line now. And there you go. There you go. So now we have two Pokemon. Sick. They can both tackle. Sick. So Coda's a software developer, I see. Probably not going to make $1 million then. Well, Mutant, Zanzu has bought shirts from the Vencabot Teespring before, and I think it went okay, for your information. But you can do it, of course, however it pleases you. Sick! Wow, Zanzu. Okay, so I have these two Pokemon, right? And they're both Pokemon objects, so they both have this tackle method. Well, let's see if it works. All right, let's try some stuff here now. Let's try Pokemon 1 dot tackle Pokemon 2. Okay, so let's see how this is going to work. Let's see if it works at all first. I might have had a typo in here somewhere with my stupid ass. Hey, it fucking works. Okay. So, it says here, Cyndaquil tackled Squirtle. Squirtle took 4 damage. Squirtle has 64 health remaining. Tackle has 9 PP remaining. Okay. So let's look at how that worked now. So, we have this Pokemon 1 object, right? He's of the Pokemon class. Right? We made this new object here. It's a Pokemon. And we gave it all these arguments, right? And these arguments get fed into a init, right here. And then we saved all these arguments as attributes on the object itself. So now we have self, it has a monster type, it has an elemental type. All these things we fed in, we've attached now to this object, to this Pokemon, this idea of this Pokemon. What's up, Roy? How you doing, dude? It's the Matrix, dude. I'm sorry, Zanzu, that's kind of a pain. Though I think only making half as much it's worth for living in the same country as Zanzu. Bet you it is. Sounds so sick. I'm interested in this, but I also feel like it's so far above my head. It's not, Roy. It's not at all. If you go back and watch our YouTube channel, you can go watch me start this project, and it's very, very simple. We do it in Notepad, nothing else, just Notepad, and typed in some very basic stuff and made a really cool game in our very first day. It takes like a couple hours. I think you might enjoy that, if you want to, that is. If you want to talk to me on Discord about it as well, it's at our Intro to Python channel. It's true for all you guys. If you guys want to join the Discord, it's at vencabot.com. That's the invite. Type in vencabot.com into your browser. Join the Discord. Hit us up on Intro to Python channel, and we can talk about Python there all day if you want. What's a PLC? Something to do with fighting games? Okay, guys, I'm sorry. So we have this these two Pokemon objects, right? They're both Pokemon, but they have different attributes. We define that in their init, right? So this one's a Cyndaquil, this one's a Squirtle, this one's fire type, this one's water type. They have different amounts of HP, different attack powers and defense and stuff, different move lists, right? But they both share this tackle method, right? And this method, it takes 2 arguments. The first one's implied, right? As we learned earlier, methods, they always take self as their first argument. So we have access to our own stuff like this, self.moveOnPP. We have access to that. But also an opponent. And we have all the opponent stuff too. When we get to Pokemon 2 here, when we feed in Pokemon 2, we get all of his stuff. We know his type. We know his element. We know his HP and his defense and attack power and stuff. We know all that stuff, which is really nice, right? So, what we get out of the whole deal is this tackle method can be used on either one. Let's actually run it both ways. Let's have Pokemon 2 tackle Pokemon 1. And then have Pokemon 1 tackle Pokemon 2 again. Let's have Pokemon 2 tackle himself. Right? Why not? I mean, it takes a Pokemon in there. Let's see what happens. Let's run it. Okay, lots of stuff happened, right? So first of all, we have Cyndaquil tackles Squirtle, right? Squirtle took 4 damage, he has 64 health remaining. Then Squirtle tackles Cyndaquil, and he takes 4 damage, and he has 51 health remaining. And once again, we have Cyndaquil attacking Squirtle again with Tackle, but now he has 60 health, because before he had 64, right? He had 64, we did 4 more damage, now he has 60 health, and then now look at this. Squirtle tackled Squirtle. He tackled himself, took 2 damage, and he lost, you know, a couple bits of health, right? There's no reason why he couldn't tackle himself, because what we know is that if we feed in, right, if we feed in a value here, right, and if this value has a move 1 PP, excuse me, the opponent that is, if he has a monster type, right, if he has defense, if he has HP, all this code will work. But what if we feed in something that doesn't have that? Let's have Cyndaquil, that's Pokemon 1. Let's have him tackle a word, right? Let's have him tackle Zanzu, right? Sorry, Zanzu, but you're getting tackled. That's life. That's life, dude. Let's run it. Okay, let's move this over. I'm sorry, guys. I forgot that I can't put things over there because of the text. Let's move this over here now. So here's what happens. We have Cyndaquil tackle Squirtle, then Squirtle tackles Cyndaquil, then Cyndaquil attacks Squirtle again, then Squirtle attacks himself, and then we get an error. Boom, we get a crash. You didn't get, I'm sorry, relax, Zanzu. You didn't get tackled. You didn't get tackled after all. Because we try to put in Zanzu as the argument, right? Quick, Zanzu, use quick attack to counter it. What's up, Raveneth? Look, I'm bored, dude. But yeah, we put in this string Zanzu, but we got an error here. String object, Zanzu, has no attribute monster type. So we tried to read the monster type, right? We tried to read this monster type. Let's just check that. Right here. Right? We tried to read our monster type off of Zanzu, but it's just a string. It's not a Pokemon. It doesn't have a monster type. Right? So we get an error message that the whole thing crashes. Fuck. Thanks for the follow, Raveneth. We program here on Fridays, talk about the very basics of programming and using Python as our vessel. And using this Pokemon example, we're trying to make this a little Pokemon thing work here. A very simple Pokemon battle. Now, previously in our last episode, which you guys can find on YouTube, we had Pokemon working pretty damn well. I'm very proud of that, guys. Very simple, no classes, only very simple concepts. You know, the most basic of programming concepts is being used here. But we had a pretty cool working version of the game, right? In this game, you can control Cyndaquil, and you fight Squirtle. And Squirtle has random moves. It's kind of like a little bit of AI and stuff. In less than 300 lines. This is the entire code right here. Very cool little game we wrote. But now we're going to try and use classes to make that code a little bit simple. A little bit simpler. They just make me a ghost type, huh? That tackle would miss. You're right. So, now we have this class, right? And now we have this data organized a little bit. Now we have this, you know, these period signs here that imply ownership. Now we can say Pokemon 1's tackle and supply Pokemon 2, and it gets tackled. Right? So it's way cooler than our old code, which kind of had these floating variables around that didn't really strictly relate to one another, just kind of like floating concepts. Now we have these Pokemon abstractions, right? We have this Pokemon thing, and it has these attributes, and it's kind of cool, I feel like. But we have some problems right away. One of these problems is that we have this move list, sure, but in Tackle, we assume it's move 1. But how do we know Tackle's move 1? We don't know Tackle's move 1. What if Tackle were move 3? Right? We're assuming too much, I feel like. So here's what we're going to do, guys. We learned today about making this Pokemon object, or this idea of a Pokemon, making it manifest in the code, right? We're making this thing in this code that is conceptually a Pokemon. It has a monster type, an elemental type, HP, attack. You know, it is a Pokemon, right? But why don't we do the same thing for a move? Have a good night, Coder. Thanks for stopping by, dude. What if we do the same thing for a move, right? What if this move is this thing, right? Let's say that a move has a maximum PP amount and a current PP amount, right? What if a move has an effect, right? Why don't we try that? So let's do that real quick. Let's go back up here to the top. We have a Pokemon class. Let's make a class Pokemon Move, right? A Pokemon Move. And again, guys, in Python, if you're making a variable or an attribute or a method, it's in lowercase with underscores separating words. But in a class name, you use capitals and to start off with, and then capitals separate words as well. No underscore, just a capital there. Pokemon Move. It's called a camel case, like a little humps on a camel. The capital letters. There's a Pokemon Move, right? Well, in fact, let's not do that yet. That's for next lesson. Let's call it Tackle, right? Class, we'll call it Pokemon Move Tackle, right? So let's say tackle, what does it have, right? Well, when you make a tackle, it's got itself. It has, well, it's really all it has, right? Because every tackle is the same, more or less. So let's say it's got, self dot maximum pp is 10, right? It's got 10 pp maximum. And when you make a new tackle, you just define a new tackle for a Pokemon. Let's say that it's got, current pp is equal to its max pp when you first make it, right? So when you first define a tackle for a Pokemon, it starts off at 10 pp, which is its maximum. All right, simple. That's all tackle has, right? Actually, let's give it like an elemental type. So self dot elemental type is normal. Tackle's a normal move, right? Cool. And then let's have this move. We're gonna give it a method called do, right? Do. So tackle dot do the tackle. Right? It starts off with self, and it's gonna have a target Pokemon. We're gonna have an opponent. Or let's call it target, right? Because some moves affect yourself, right? Like what's that move called? Like mirror move, but not really. Metronome, not really. Some moves, I'm sorry guys, I'm drawing a blank. Some moves affect yourself. Destiny Bond, something like that. In any case, do has self and a target, right? So now let's get our code from tackle down here. Right, I'm going to copy paste this code. I'm not using Vim. Let's get all this code here. Double edge, thank you, yeah, double edge, that kind of thing. Thank you, Faust. Moves that might grow your stats, that kind of thing. Okay, so here's what tackle would normally do, right? But now we know our PP. We know our current PP. So we're going to say, hey, listen, if self.current PP is 0, then print off, tackle has no PP remaining, right? Return it. After if it has no PP left, we're done. But now we can say, oh, we need to know our actual what Pokemon is doing the move, right? So, why don't we feed in like a parent Pokemon, right? Like, let's just call it, owning Pokemon, right? We'll call it owner, right? Self.owner. Right? We're gonna say, hey, listen, self.owner is owner. So whatever Pokemon has this move is the owner, right? So let's just say owner.monster type tackled the target.monster type. There you go, right? There's a damage. That would be our owner's attack power minus a target's defense. Excuse me, a self.owner, right? Because we have this owner object. Okay, I'm just going to break this line here now. All right, explain some in a minute here, guys. Okay. There's the damage calculation there. So we're going to say a target.HP. We're going to reduce the target's HP there. Okay. Opponent monster type, that's fine. Actually, we're going to give this a name too. Each move has a name. So self.owner is that. We're going to say self.move name equals tackle. There you go. I'm sure we're going to use that in a minute. Okay, we're going to say, the opponent monster type took damage, whatever. That's fine. It's not an opponent, it's a target now, though, not an opponent. Target, actual damage, that's fine. Target, there you go. Self.pp, or current PP we're calling it, is self.current PP minus 1. So we're losing some PP on this move now. And we're going to say, self.current PP remaining. Okay, so let us try to use this new thing we made. So we have this thing now called a tackle, right? It's a class now. It's a conceptual object that has its own attributes, right? The move has an owner. So let's say that it's, Cyndaquil's tackle. We know it's Cyndaquil. It has a move name. It's tackle in this case. It's got a maximum amount of PP, which is 10 in this case. And it's got a current PP, right? So it might have 10 maximum, but as you use it, it's going to get used up. The current PP is going to be less than the max. It starts off at max though, right? Whatever our max PP is, that's what it starts off at. And it has an elemental type in this case, which is going to be a normal type. Okay, so we run this this do code. We'll actually execute the tackle itself. So when we execute tackle, we find out, hey, we got PP left. If we do, good. If we don't, then it's end right there. Right, this little message here says print tackle has no PP left. We're done. But if we have PP left, we go down here. Right, it prints off a message for the player to know what happened. It does some calculations on damage here. It lowers the opponent's health right here. Prints off more stuff for the player. Very simple. And then it subtracts, some PP from itself. It's got ammo, limited ammo in Pokemon. It has one less ammo now. We used it once. Then it prints off the remaining ammo, or PP in this case, as it's called. Okay, so interesting, right? We have this move now called Tackle. Let's change the way our Pokemon class works. It doesn't need to know PP anymore. Let's get rid of all these PP values. Because now the PP is saved to the move itself. Okay, no more PP for the Pokemon. Now the PP is saved to the move. Okay, interesting. We can remove this method here as well. All right, this tackle method. Because now it's a part of do here instead. Actually, I put a blank line here. Usually I want to put 2 blank lines between classes. Just to make it easier to read. Okay. So now we have this new thing called a tackle. Right? We have 2 kinds of things now. Right? These 2 kinds of classes. We have a Pokemon who has all these attributes. And we have this tackle, which has these attributes and this method. Do the thing. Right? Do whatever this move is. Okay, so why don't we make a tackle for our first Pokemon, right? So let's make a Pokemon here. He's got, this empty list as his move list now, right? He starts off with no moves at all. Might even fit on one line now, do you think? Oh, isn't that pretty? So we have 2 Pokemon, right? Neither one has any moves. They've got names, they've got types, that is. They've got elemental types. They've got HP and defense and attack power. And that's it. They also have PP. They don't need that PP anymore, right? Let's get rid of all that stuff here. Cool, much tidier now. Okay. There. So we have these 2 Pokemon, right? What do they have now? Well, now they've got a Pokemon type, Cyndaquil or Squirtle. They have an elemental type, fire or water. They have HP, attack power, defense, and a move list. Okay, so let's see what we got here. Make sure we're on the same page here. Type, elemental type, HP, attack, defense, and move list. Okay, so very simple. They're simplified now. No more PP for the Pokemon, because now that PP is saved onto the move itself. Okay, let's make a tackle now, though. So we have 2 Pokemon here. Simple. Let's make a tackle for Cyndaquil. Smell of an energy drink. I don't think you got like some taurine in there. So we're gonna say, Cyndaquil tackle. This is his tackle. So would it be a new PokemonMove tackle, right? And it only takes a couple of arguments, right? It takes an owner. That's it. So we're giving it, our Pokemon 1. That's Cyndaquil. So Cyndaquil has a tackle, right? Now we're gonna actually put that in his move list as well. So we're going to say, Pokemon 1.move list. Here's a move list, right? And the move list is an empty list, right? Let's see where's that defined at. Right here. So there's a move list right here is his last argument. It's saved right here. Self.moveList is the move list argument. We would supply an empty list, right? But we're going to add in this tackle to that list. So now he's going to have a tackle in his move list. But how do we do that? Let's go check our documentation. So let's go to docs.python.org. That's the documentation for Python. Go to the library reference and look at the sequence types. List, tuple, and range, right? Let's read about the methods of a list type. What we got here? Let's scroll down a little bit. I'm going to find one here. Okay, right here. Append. Right, so you have this list here. It has an append method. It adds X to the end of the sequence. Okay, so we can add a move like this. So Pokemon.moveList, that's a list. Append is a method of any list. Right, so it's owned by this list. You can see the little period there, apostrophe S. And we're going to append in Cyndaquil's tackle. We just made that. And the burn it gives. I haven't drank an energy drink in a long time. Okay, so here's what we're doing, guys. We made 2 Pokemon. I'm actually going to break these lines up a little bit. Well, why now, Zanzu? Think it's going to make you feel better? You're still kind of sick a little bit, right? Okay, so we defined 2 Pokemon right here. Then we defined a tackle right here, right? PokemonMove tackle, this thing. And it takes one argument, which is the owner of that tackle, which for our purposes is Cyndaquil, Pokemon 1. And then we're making sure that Cyndaquil knows he has a tackle now. So we're saying Cyndaquil 1's move lists append method, right? So Cyndaquil's move lists append method supplied in the Cyndaquil tackle. So we're appending this move to his move list. So now he has a move. Cool, right? Dare I say fucking cool. He has a tackle now. Why don't we try and use it? So let's just say, you know, Pokemon 1 dot... Let's just execute it. Let's just execute it. So we're going to say Cyndaquil tackle dot do... We're going to do the tackle to, you know, Squirtle. Pokemon 2. See if this works. It might not work. I might have had a typo in here. Let's find out. Yeah, we have a problem here. Opponent's not defined. So what line is that on? Line 30. I didn't change one of the opponents to a target. Let's see here. Right here. We need the target HP, not the opponents. We have no opponent anymore. We're changing our wording around. Let's try that again. Okay. Run. Module. There we go. Okay, so here's what happened, guys. We got Cyndaquil tackled Squirtle. Squirtle took 4 damage. He has 64 health remaining, and Tackle has 9 PP remaining. So same as before, right? But now we have this abstraction, this notion in our code of a Pokemon move. Right? So now we have this Pokemon as an abstraction, as a notion. He has, you know, we know that Pokemon have a monster type, an elemental type. They have HP, attack, defense, and a move list. We also have this thing called like a move. Right? Moves have an owner, whoever owns that move. They have a name, like Tackle. They have a maximum amount of PP they can have, and a current amount of PP they have, and they have an elemental type, just like in Pokemon, right? And we know that moves have a do method, right? When you run the do method of that move, it actually targets some Pokemon and does a thing. Right? It's kind of cool. Interesting. Well, let's do the same thing. Well, before we do that, let's talk about other ways we can use Tackle. In this case, we actually are calling do right on Cyndaquil Tackle. Right? So here we made Cyndaquil Tackle. Right? We made it into its own thing, a PokemonMove tackle. And we give it an owner, which is Cyndaquil, right there. And then we're running it right here with the do method. Right? That's its do method. We're running this from that thing. We know that the owner in this case is Cyndaquil because we defined it right here. Right? But also, we append it to this list, right? It's part of this move list now. Pokemon 1's move list. We actually call it like so. We can say Pokemon 1 dot move list 0 dot do on Pokemon 2. Okay, now that's pretty complicated, right? What the fuck does that mean? That's a bunch of random numbers and letters, right? That's what it seems like. Well, we know Pokemon 1 is Cyndaquil. We defined him right here. And we know his move list is a list, right? Which means you can give it an index to pull some data out of that list, right? So 0 is the first thing in the list, right? We talked before about how 0 is the first index. It's not 1. You'd think the first thing would be number 1, right? But no, in programming, most languages, the first thing on the list is 0. Then the second thing is 1, third thing is 2, etc. So we have this 0th item in the move list, and we're doing that thing off of that. So we know his first thing in his move list is Cyndaquil Tackle. So we're calling Cyndaquil Tackle by another name. We're saying Pokemon 1's move list, whatever's in the 0th spot, do Pokemon 2. Why do you need to define Cyndaquil Tackle? Why don't you just append Pokemon Tackle? Oh, we can. We can do that, Skull Crusher, but here's why we can't. Because the move has a current PP. Right? So we could actually do it like this. We could say, hey, listen, append in, let's get rid of this altogether. We just append in the actual class, right? He has Tackle, right? He has a Tackle. But shouldn't all tackles be the same? Let's just say, you know, Pokemon, move, tackle. Because all tackles are the same, right? Well, that's an awesome idea. I think you're a genius. I'm going to keep on talking though, Skullcrusher, but you're a genius though. We're going to change this actually right now. But anyway, he has this move, Pokemon Move Tackle, right? It's a class. He has one of these things. But the problem is that every Pokemon move has to have unique attributes. It has to have an owner, It has to have a current PP, right? So we need an instance. We can't just supply a class. We need to supply an instance, right? Because not every tackle is equal. Not every tackle has the same amount of current PP remaining. Not every tackle has the same owner, right? That's why we have to make a yeah, that all the same. But Skull Crusher, you gave me an awesome idea, dude. Thank you for being in the chat. Here's what we're gonna do. Let's change this, right, guys? It's kind of crazy. Let's do something here. We have this list, or this empty list, right? Oh, guys, this might be a little bit advanced for you guys. Let's just do it anyway. We have an empty list, right? Let's put in this class, PokemonMove Tackle, right? Get rid of all this appending shit. Fuck all this shit. Okay, so now we have this move list, right, Skull Crusher? And it has a PokemonMove Tackle in it. It's a class. It's not an object. It's just the abstraction of the class. But what if we said for... Oh, it's actually, here we go. We'll say self.moveList is equal to an empty list, right? We're going to say for PokemonMove in our supplied move list. All right, so that's, we talked about for last time, right, guys? For is a loop, and it loops over every item in a list, and it calls that item whatever variable name you choose right here. So for everything in the move list, we're going to call that a Pokemon move and then do something to it. We're going to say for Pokemon move in move list, let's say self.movelist.append. So we're going to add a new move to our move list. We're going to add in PokemonMove self. Kind of confusing, right? A little bit confusing. Let's talk about what that means. I bet you Skull Crusher already knows what that means. He's a pretty smart guy. Here's what we're doing, guys. We're supplying in the class, right? PokemonMove Tackle, it's a class. In fact, we're going to call it right here. Let's call it PokemonMove class, so we're clear. Right? Just so we're all on the same page here. So we supply in a class, in a list. Then for every class in that list, we're making a instance of that class. And we're supplying ourselves as the owner, right? It takes one argument, which is owner, right? So for every move in this list, every class in this list, we're making an instance of it. Because again, when you do a for list, or a for loop that is, it goes over every item in the list, and it gives it this name temporarily, right? So for every time it loops, that new item in the list gets this name, PokemonMove class. So what we're saying here is, on our empty move list right here, we're adding in another item to that list. And that item is whatever our current class is that we're looping over. We're making a new instance supplying self as the owner. Okay? So we can make more moves and add them in this list right here. And every time it loops over it, it's going to make an instance of that move for that character and save that. Okay, I apologize, it's a little bit complex. If you guys have questions, please let me know. Let's run it and see what happens, just so you guys know what's going on here. So once again, we're going to tackle Pokemon1 dot move list 0, like the 0th item in the move list, dot do to Pokemon 2. Okay, so if I'm not mistaken, this should make this tackle work. I'm going to go over it again for you guys, because it's a little bit complicated for a beginner course. But it worked. Okay. Alright. So there's the tackle thing, it just works like before. But let's talk about one more time why it works. Let's talk about for loops for one thing. Because for us on the stream here, for loops are kind of new. They're kind of new. So let's go make a new file here. And I'm going to save this as, for loop example.py. Okay, so let's talk about for loops, guys, real quick. We're going to say, we're going to list, right? So we're going to say my list equals, let's just say, make the color list again, right? Remember the color list from before? Color list equals, red, yellow, blue, purple, orange, right? Pretty simple. Pretty simple little list of strings there. Thank you, Mutant. Thank you. I see that you put a message in Discord. I'll read that between streams here. Okay, so we're now going to make a for loop, right? So we talked about while loops before, right? We can say while some condition is true, right? then, loop forever. In this case, because, true is always true, right? They'll loop forever. But we also have another kind of loop called a for loop. Now, for loops go over every item in this list, right? So we're going to say for color name, right? Color name in color list print color name. Let's just say print this color is plus color name, right? Cool beans. Let's run this code here. There you go. So here's what happens, right? You get this color is red, this color is yellow, this color is blue, this color is purple, this color is orange. Right? So what's happening here is that for every item in this list, it's getting this name, color name. It's like assignment, right? It's like a variable assignment. And for every item in that list, we can use it using that attribute, using that variable name. So for every item in the list, right here, it's becoming color name, and we can use it, and then loop to the next one. If Pokemon moves like tackle can differ between Pokemon, should we be passing in arguments for each attack in init? So append Pokemon move tackle 10-4, etc. And yeah, I didn't know you needed to make a defined instance of each move per Pokemon. Smart, but not that smart. Well, let's talk about it. Yeah, I'll message you when the stream's over here. We can talk about the Jazzy online tournament. We should already be ending right now, in fact. But let's talk about let me talk about loops. I'm sorry. Let's talk about for loops real quick. That's how they work, right? They take a list, right? Here's the list right here, and then for every item in that list, we get a variable. We're calling it color name in this. We can call it whatever we want. We can call it whatever we want. And then in the indented code block, we can use that item from that list, right? So here we're going to use whatever we want. There we go. And now we have access to this item in the list. We loop over till the list is through. Right? You go through the entire list until it's done. Right, let's run that. See, it prints off everything, every color name until the end of the list, and it ends. But let's go look at our code here and let's see what Skullcrusher's asking here real quick. Okay, so should you enter in, if Pokemon moves like tackle can differ between Pokemon, should you be passing an argument for each attack in init? No, let me tell you why. Well, it's because we have this do function here, right? So whenever you do tackle, you supply a new target, right? But when you define tackle, you're just defining these attributes here. So you don't really have to supply in the numbers for each new tackle, because tackle is mostly the same. Tackle is mostly the same here, right? The only way they really differ is in their owner and in their PP amount, right? You don't really know Pokemon that well, huh? Well, basically, every tackle is the same. It's just that they can have different amounts of ammo left, right? So imagine you have like a gun, right? Let's say you have like two revolvers, right? Two Colt 45s, right? They're both the same type of gun. They're both the same. They do the same thing, but one might have 4 bullets and one might have 6 bullets in it, right? So they do differ, but they do the same exact thing the same exact way. That's how Pokemon works. In Pokemon, every tackle is the same. It's just that they're owned by different Pokemon here, and they have different amount of current PP left. So in that case, the do function can always be the same. I'm sorry, I moved that there. The do function can always be the same. In this case, tackle always behaves the same. It's just that its current PP might differ from tackle to tackle. So for that reason here, we instance it right here. Right, we instance it with self as the owner. And then from then on, we can use it with this do function, this do method, I should say. So Mr. Anderson says, but since Python doesn't have private access control, you can still mess up the object from the outside. That's true, but you can just, it's, you shouldn't. You shouldn't. It's considered to be the honor system. You can, in Python, you can use, if you define a method or something like that with this, a single leading underscore, that means don't mess with that. Here goes the annoying thing about Pokemon, yeah. Basically, every move is kind of like a weapon that has ammo. Think of it that way. The weapon type itself is the same, does the same thing. You can have a rocket launcher. They're always the same kind of behavior, but different amounts of ammo. And again, they have a different owner. They're owned by different Pokemon. So let's say, you have two different tackles conceptually. One is, my tackle, one's your tackle. That Marvel 3? In Python? That'd be pretty cool. Maybe one day. Unlikely. Okay, guys, I'm actually going to lower the volume here a little bit. So, we have this one move, which is, tackle. Cool. I think next time we should talk about inheritance on our next Python stream. Guys, I just realized next Friday is Yumacon. It's a big tournament here in Michigan for fighting games. I'm a fighting game player. I'm not going to be here on Friday, guys. Again, I program on Fridays. It's really fun to hang out with you guys, but I'm going to be missing next stream. I'm going to be playing, Street Fighter next week and Mega Man Legends next week, but on Friday I'm going to be gone. So you guys are going to see me again doing programming on what date? We're going to be programming again on the 9th of November. So if you guys don't see me programming for a while, I apologize. We do want to keep doing this every Friday on the channel, but again, I'm not going to be here next Friday. I can't control that. But on the 9th of November, we're going to come back to this code and look at instancing variables, right? Like, inheritance, right? We're going to make a class called a PokemonMove, and things like tackle and flamethrower and minimize and quick attack. They're going to all be Pokemon moves that inherit from this one master type of class, but they're going to have their own things going on as well. Let's see here. PokemonMove tackle. Before I leave, though, let's see here. So Zeeth says, I got confused. Self.movelist is different from movelist. Yes, it is, Zeeth. Because move list is an argument. We got fed in the move list, right? And so self.movelist is a attribute of our Pokemon, right? So it's a pretty common practice in Python and other languages as well to use the same name as the argument as the attribute, but they are different things. Here you see, like, self.monsterType equals monsterType. What we're saying here is, the attribute of this object, the monster type, is equal to whatever was supplied as the monster type argument. Right? So self.monsterType is equal to what we know as monster type right here. That's what we're saying. In this case, again, the self.moveList is an empty list we're making. And then we're saying for every class we supplied in the moveList argument, right, do this thing here, which is to say define instances. See, Skullcrusher says, can you define max PP? Is that how much ammo you need to use the ability? Like mana cost, exactly, Skullcrusher. PP is exactly like ammo. It's not like mana in Final Fantasy or whatever. Every move in Pokemon has a limited number of uses before you rest. So think of it like, I have 10 uses of tackle, right, which is what we defined it as. So every tackle starts off with 10 PP, that's its maximum. And then as you use it, its current PP will be reduced. So it'll lose PP over time, right? Every time you use it, it goes down by one ammo. And the reason why we define a max is that when we rest again, let's say we go to like a Pokemon Center or like a hotel in Final Fantasy, our PP is restored. We have to know how much to get, and that's our max PP value. So when we rest, we're going to get our current PP back to our maximum PP, right? It's like mana cost, kind of. Double programming stream, huh? On the 9th? I don't know. It depends on what kind of viewership we get today. So when I end the stream, guys, I'm going to look at the analytics for Twitch and see if there was a lot of interest in this stream today. If there was, I don't see why we couldn't do a double stream on November 9th to celebrate us missing one. Always talk about PP, Steve. Always talk about that PP. You guys know me. Okay, cool. So let's see here. This code is not as functional as our old code. Let's go back to our old code, guys. Our old code here is our, the one that has no classes yet, right? It's just a bunch of loose data and then a big loop for combat. Right, let me actually run this for you guys. Thank for the follow, CK Remix. And we program here on Fridays. Every other day we do gameplay, mostly. But next Friday I'm going to be AWOL. I got business on next Friday. So we're not going to see any more programming again until November 9th. Please be patient, guys. I apologize about that. I wouldn't normally want to put that much time between programming streams, but sometimes life happens. But yeah, on November 9th, we're going to return with more programming. Until then, it's going to be mostly gameplay on the channel here. But yeah, so let's run our old code here. So in our old code, we have a pretty cool little combat system, right? Very basic. Let's see here. Cyndaquil's got moves. Their tackle, flamethrower, tail whip, and growl. Squirtle has moves. We can choose our move here. We can choose, like, flamethrower. And something happens there, right? Cyndaquil blew flames at Squirtle. He took 4 damage. Squirtle has 6 HP left. Flamethrower has only 4 PP remaining. Started off with 5. Then Squirtle used tail. Now Squirtle in this one uses a random attack. Squirtle's a random attack here. He has a little bit of AI, which is he chooses moves at random. And we do this until we die. We keep on looping and looping until somebody dies, right? It's kind of cool. In our new code we made today, we started over from scratch to learn about classes. And by doing so, we kind of lost some progress. We're kind of back at square one. We have 2 Pokemon again, which is cool. And we have Tackle working, which is great. Actually, I'm going to delete this function up here. But on November 9th, we're going to actually fully realize our old code, which was that little combat function where we can fight until one of us dies. We're going to realize that using classes. It's going to be awesome, guys. It'll be a little bit simpler, a little bit easier to understand, trust me. But it's going to be a little while before we can do that, I'm afraid. That kind of sucks. What if we want to use Squirtles? We can do that if you want. Let's run this code again one more time. Run it. Okay, so Cyndaquil took a tackled Squirtle. Okay, well, we have Squirtle here. He has no moves, right? Let's give him a tackle. Let's give him a tackle. There, now he has a tackle. That's cool. Now we can have him tackle us back. Print a blank line, though. We're going to say Pokemon2.move list. The 0th move, which is tackle for him. We're going to do that move on Pokemon 1. Same thing happens. It happens when Cyndaquil does it. It just uses, Squirtle's stats as the attacker and Cyndaquil's stats as the receiver. Boom, there you go. Right, so Cyndaquil tackled Squirtle. Squirtle took 4 damage. His HP was reduced from 68 to 64. Tackle has 9 PP remaining. Then Squirtle tackled Cyndaquil, and Cyndaquil took 4 damage. Cyndaquil has 51 health remaining, and Squirtle's tackle has 9 PP remaining as well. So same thing just happens, just, their stats get swapped. The attacker becomes a defender and vice versa. You can also tackle yourself. We just explained it before, right? Because the way our code works right now, the target, let's go up to the tackle up here, right? The target here is whatever. You can supply whatever there. Oh, what if Cyndaquil used Squirtle's moves? Well, he can't, because of the way we have our owner set up. Right, so let's talk about that. So we have this, our move has an owner right here. As soon as it gets defined, we get an owner. Right, and once it's defined as an owner, we use that owner code here, right? Self.owner.monster type, like, Squirtle tackled so-and-so. Then we say, the owner's attack power, is, it helps calculate the damage there. And when we define the move list right here, we have this move as an empty list, right? Then for every class in the move list, we make that move, and we define the owner as self right here. So for everything in our move list, we make that move attached to ourself. So right here, when we run this code, let's kind of feed in right there, we're making a tackle that's attached to ourselves. So to get Squirtle to tackle a different max PP, we could use the random one, Craig. Yeah, if you want to. Yeah, let's do that. We'll give a random attack power instead. That'll be more fun, right? Let's go to the attack damage. Right here, the calculation for attack damage. Well, let's just do your suggestion, right? Random PP. So for every time we get a tackle, let's give it a random maximum PP. We're going to say random.randint. We can give it, between 1 and 10 if you want. Let's do it something crazy. Let's do it between, let's do 1 and the maximum of 50. Hashtag PP. Let's go. So now they're not equal anymore, right? Every time we define a new tackle, it gets a random PP. So Squirtle's tackle might actually be better than Cyndaquil's tackle now. That's crazy. Let's find out what happens here. Run the module. Okay, yeah, so look, when Cyndaquil tackled, he had 69 PP at first. Now he has 68. And when Squirtle tackled, he had 42 PP. Now he has 41. Can you use a move list, a PokemonMove tackle .do instead of 0.do? In case they ever change in the future. Yes, you can, Skull. I would love to talk about that. I think I will. We're going to run a little bit late, I feel like. To talk about dictionaries. Skull Crusher. Dictionaries. So, right now we're referencing the moves by their number. Right? Which is kind of ugly, kind of hard to read, right, Skull Crusher? It's kind of hard to know what we're using. Then we can't reorganize our moves. It's always stuck on the 0 slot. But we can use a dictionary, right? Let's talk about that real quick. I'm going to make another example here. We're going to run probably about 10, 20 minutes late here. I apologize. So you guys are excited about RuneScape. Make a new file. It's our first time ever on stream talking about dictionaries because we're all beginners here today. Let's save as dict example.py. Thank you, Zanzu. Very patient. Okay, but I want to talk about dicts today, Skull Crusher, but I kind of ran late. I figured I'd save that for next time. Let's do it right now. So we talked about lists, right? Let's talk about the color list. Right. The color list is a list of data separated by commas, like red, blue. No, Skull, you're awesome, Skull. I appreciate your help here, dude. If not for you guys, it'd be hard to host a stream like this. Having questions gives me some idea of what to talk about. Red, blue, yellow. There's this list, right? Pretty basic. We can access the list using numbers. We call it indexes. So we can print off, color list 0. Right? Cool. Let's actually demonstrate that right now. Run the module. Okay, it prints off red, right? Because red is the 0th index in that list. However, in Python, we have what we call dictionaries, also known as maps. So let's talk about that right now. Let's have like a color map. Well, it's called color dict, right? Color dict. Now, a dictionary, it has curly brackets around it. So lists have square brackets, right? And dicts have curly brackets. Now, what the fuck is a list? A dictionary? Well, a dictionary associates two types of data, two pieces of data. And then when you feed in one, you get the other out. It's kind of complicated. Let me demonstrate. It's easy to see in practice. Let's use a string here. We're going to say apple. And we're going to associate it, boom, with a colon, with red. That's our first thing in our dictionary, right? So we have this apple key, it's called. We're using the key of apple to get red out of this dictionary. It's a map. It maps one thing to another thing. We're going to say banana. Map that to yellow. Okay. Then we're going to have grape. Map that with a colon to purple. Okay. There's our dictionary, guys. So our list is just 3 pieces of data separated by commas, right? And they're accessible by number. They're index 0, 1, 2. Right? What's up, Dix? Steve. We have this dictionary now, this color dict. It actually associates data, right? We have this apple, and it's paired with red. We have a banana. It's paired with yellow. We have a grape. It's paired with purple. Right? Let's use that now. Blue is not purple, yeah. Some grapes are purple, aren't they? A color list here. Let's print off color dict, right? Yellow. Excuse me, banana. There you go. So we have this color list. We feed it a number, which is an index, right? But for a dictionary, we feed it in a key, which is the first item in this pair. So if we feed in banana, we're going to get yellow out of it. Let's demonstrate that. There. So we've got red, which is color list 0, and we have yellow, which is color dict banana, right? Now, it doesn't need to be strings. We have all strings here, right? We can actually feed in objects, too. It could be like, our first item could be a Pokemon, or it could be a move, or it could be anything, really. And that can be paired with any other kind of data. So it's a really, really handy tool for getting data in a way that's very easy to read for the programmer, or in a way that's not organized, numerically, basically. So let's utilize that here in our move list. This program is it's a Pokemon combat simulator. It's a Pokemon combat example. Our previous, in the past 2 streams, we've made this example, which is a beginner's tutorial where we've made a Pokemon combat system with no classes. It's very, very basic ideas. If you're first day programming, you can do this. Check that out on YouTube at youtube.com/Vencabot archive, or just search on YouTube for Vencabot. You'll find my playlist there of Intro to Python. It's like a little playlist of videos. This is our Pokemon example. For your first day programming ever, we get a working version of Pokemon, kind of. by using very basic concepts. Today we're covering a little more advanced stuff like classes, by taking this code we had working before, starting over, and using classes instead. Exactly. It's kind of weird, Skull Crusher. That's kind of weird, I feel like. But you're right. Let's talk about that real quick. So, even though we defined the list with square brackets, and we defined the dictionary with curly brackets, when you access the data later, you always use square brackets. So in Python, think of these as like, the data accessor, right? From something like a list or a dictionary, right? When you define a list, you use square brackets. Define a dictionary, use curly brackets. But when you access data, you always just use the square ones. So color list, 0, that's the index with square brackets. Color dict, banana, that's the key with a square brackets around it. It's kind of weird. If you did curly brackets, it wouldn't work. That's not a thing. That's not a good Python syntax. You want to use square brackets when you access data. But yeah, so here you have an index, here you have a key. You got a license for this stream. What's up, Machine? Looking bored, dude. It's almost time for RuneScape. But first, let's talk about my man Skull's question. Can we access this move in a more sensible way using a dictionary? Right here. So we have right now we have PokemonMove list 0.do. Right. Well, preemptively, guys, knowing this would come up, I added an attribute to each move. Right. It's called move name. Remember that? Remember we did that, guys? Now, why would we do that? Because I wanted to use that later as a key in a dictionary. So here's what we're gonna do now, guys. Now our Pokemon's move list is not a move list anymore. It's a dict. Right. That means we have to supply it with like that. Right. Empty dictionary. Right, so I have this move dict. Right. What's going to happen is for every move class in the supplied move list, remember this? We get this move list, right? We're going to do this. We're going to say, get rid of this code here. We're going to say self.moveDict. We gotta make the move first. We're going to say, new move equals Pokemon move class self. Right, so we have this new move now. Right? So we have this tackle, hypothetically speaking. This tackle, this new tackle instance. Now we're going to say self.moveDict new move.move. Excuse me, I don't need this quotation mark there. New move.moveName equals new move. All right, so what does that mean, do you guys think? Well, let's talk about it. What we're saying is, we made a new move using the move class we got, right? So here we fed in a move class, which is Pokemon Move Tackle. So in move list, it needs to go to move dict. Yeah, because we have this move. We have a move list as an argument still, right? This is a move list. Move list is our argument. So it's still a list. It's still a list of classes, right? Move classes. So for every move class in that move list, we make an instance of that move, right? So we have this new move, and it is our Pokemon move class. We've given a new owner, which is self, right? So we have this thing. We have a tackle, right? Our first move is tackle. We make a new owner, which is ourself is the owner of the tackle. Boom, bingo. But now we're going to add a item to our dictionary. So when you assign to a new key, we talk about defining a dictionary. Let's actually go back to our example here. I'm sorry, guys. I know I'm talking kind of fast. Let's go back here real quick. So here we define a dictionary, right? And here we access the dictionary. But you can actually add things to it really easy. Let's go, let's just say, color dict, what's a good example? What's another fruit? Let's just say broccoli. That's a fruit, right? I don't know how to spell broccoli. I hope that's right. That's not, is it? Oh my god, I'm so stupid, guys. I don't know how to spell broccoli. Oh my god, let's not use broccoli. I can't spell it. Let's use carrot. Alright, so we have a carrot, right? It's going to be equal to orange. So that's how you add stuff to the list, right? Use an assignment. It's kind of like assigning any value, right? Like color list, we use an assignment there. We use an assignment here. And here we assigned orange to a brand new key in color dict. Right? Yeah, that too, Mr. Anderson. You're going to assign itself to itself. But yeah, so you don't use curly brackets for defining a dictionary, Zanzu. We defined it here with curly brackets, but when you access it, you use the square brackets. Same with the list. It's kind of confusing. I'm not sure why they did it that way, to be honest. But yeah, so that's how you assign a brand new item to a dictionary. You simply just assign with the equals operator. You say, here's my color dict, here's my new key that I want to use, and here is my new thing I want to assign to that key. So this is the same thing as, defining a new dictionary. Like you can say, new full dictionary. You can define it like this if you want at first. Like, apple red, banana yellow, grape purple, and, carrot orange. All right, easy. Excuse me, I want a curly bracket there, not a square one. Easy peasy. Just break that line. Just like that. Easy. But unlike a list, we have to use that append. Let's say we want to add a new thing to our list, right? For our color list, we have to say, like, color list dot append orange. That'll add in a new item to that list. In the case of, well, actually, there's a way to do that without append, which makes sense, but we'll talk about that later, I guess. But you commonly use append to add to a list, whereas with a dictionary, all you gotta do is make a new key and assign it like this. Very, very simple, very clean, right? So when you define a dictionary, it's like this. But you can also do this. We can also have done like something like this, right? Here's another example. We can say, new color dict is an empty dictionary, right? Totally empty. And then we can say, new color dict red, apple equals red. New color dict banana equals yellow. New color dict grape equals purple. And new color dict carrot equals orange. So there's multiple ways to get data into a dictionary, right? You can define it with all of its data already, like so. Or you can add stuff to it using this kind of syntax right here, right? You make a new key, and then you assign to it, very simply. So here's an empty dictionary, and we assign all of it, manually for each individual key, versus defining it all at once with this syntax here, or this syntax up here. Okay, so let's go back again to our Pokemon code and see what we did here. So in this case, we for every move class we get in our move list, we only have one right now, which is PokemonMove Tackle. We make a new of that thing. We make a new instance of that thing, which is a tackle, right? So we get a new tackle here with self as our owner of that tackle. We use owner again for messages in this case, mostly. Right? We use it for our monster type. We can say, Cyndaquil tackled so-and-so. We use it for the attack power calculation. We gotta know who the owner of the move is, right? So we give ourselves as the owner of this new move we made. And then we're saying for our move dict, give it a new key of whatever our move name is, right? And have it equal this move. All right, so what does that mean? Well, here's what we can do now, guys. Let's go check it out. It's kind of cool, kind of really cool. Now we can say Pokemon1 dot move dict tackle dot do on Pokemon 2. All right, let's demonstrate that. Run a module. There you go, it worked. All right, Cyndaquil tackled Squirtle. There it is. And that's because we have this dictionary, this new move dict, right? And it has this key. This key is tackle. Because we did it right here, right? Self.move dict, our new move.move name. The move name is tackle, right there. Right? So we have a dictionary now, and it has a key for tackle. And the key for tackle points to this move, the tackle. Kind of cool, right? So we can access it very easily now. And do the same thing for flamethrower. Same thing for scratch or tail whip or growl. Now the downside of that is we don't have indexes anymore, right? So now there's no more move order. Now again, we're making a very simple Pokemon example. In actual Pokemon, you do indeed have an order of moves. You can sort them as you wish. Right now, for us, we can't. Our move list is in a random order now because dictionaries are not ordered in any way. They're just floating data with a key and then data attached to it, right? Key and data. They're not in any kind of order internally. But thankfully, in Pokemon, the move order is not important at all at any level of play. So we're not going to worry about indexes anymore. I think that having a dictionary makes more sense, right? Accessing it by the move name makes more sense, especially because in Pokemon, you can't have two of the same move. Exactly, a lot more readable inline, right? You know what he's doing now. Instead of having to do that thing with the index of like 0, it makes no sense. You have no idea what the hell that means. But let's talk, before I quit now, about overwriting keys. Because I just thought of that, right? Pokemon cannot have two of the same move. But what if they did? Right? What if, you could have two tackles? Well, now our code is broken. Skull Crusher, it's broken now. Because in a dictionary, you cannot have two items that have the same key. Let's demonstrate that real quick. So let's just say, let's delete all this, right? We're going to make another color dict. Why is this line all highlighted? Thank you, Mr. Anderson. Thank you. Color dict, we're going to say, we're going to give it, apples are red, right? And bananas, they're yellow. That's fine for now. But let's just say, let's print color dict apple. We're going to get red out of this, right? You guys know that by now. Let's be sure of it, though. Run the module. We get red, right? So we get this red value now. It's printing off whatever's apple in that dict. But now let's just say we go color dict, apple equals green. We've got a green apple now. Let's actually put some blank lines in here. It's a little bit crowded, I feel like. Now let's print color dict apple. Right? Well, it's going to say green now, right? Yeah, now it says red, then green. It says red, then green. That's because at first it's red. Right here it's red. Then we change it to green. And now it's green. But what happened to red? Well, red's gone, guys. It's garbage collected. That's a thing, in Python. Once you no longer have a reference to a piece of data anymore, let's say that nothing in our code points to red anymore. That means that to save memory, red is deleted from memory. So red's gone now. So for a Pokemon example, right, let's say that, hypothetically speaking, in some hack of Pokemon, you could have two tackle. You have 4 moves, right? Let's say 2 of them were tackle. Sounds like red, no! It's okay, we can always get red back again by restarting the program. But let's say we could have 2 tackles, right? The problem with our code is that we save our moves in a dictionary by the move name. So we can only have 1 tackle, because as soon as we get another tackle, the old one gets overwritten. The move name tackle gets overwritten with this new move. So our code would be bugged in that case. Thankfully, again, in Pokemon, you can only have 1 move of a certain type in your list. But we could actually, we could fix some stuff. We could say, if we want to fix that bug, we could say, if, new move dot move name in self.moveDict.keys. Oh my god, guys, kind of complicated, right? Then say, new move.move name equals, new move.move name plus 1, right? Hypothetically speaking. So what does that code mean there, guys? Well, that would fix our bug. We're saying, hey, listen, we got this new move, right? And it has a move name, which is tackle. However, if that move's name is already in our keys, this is a method of a dictionary, right? Let's take a look at that real quick. Okay, so we have this these mapping types down here. We've got lists, blah, blah, tuples. Where's our mapping types? Text data sequence. I'm sorry, guys. Let me go back here. Dictionary. So it has this this method called keys, right? There it turns a new view, it's like a list, of that dictionary's keys. Okay? So it returns a list of the keys, basically. So we're saying, hey, listen, if that move name is already in our dictionary's list of keys, well, then don't use that move name. Instead, change the move's name to whatever it was plus 1. Right? So now we have tackle and we have tackle 1. Right? So now we have both tackles, different names, and that way we don't lose anything. Right? But thankfully, Pokemon, we don't need to worry about that. We only have one tackle anyway, so that's just an example for you guys. I'm going to call it a day here for Python, guys, and come back on November, what did I say, 9th or 6th? Man, it's a long-ass way away, isn't it? Holy shit. November 9th. Man, I'm sorry, guys. So on November 2nd, I'm going to be at UMACon this year. So I'll be back with more Python on the Friday of November 9th. And that day, we're going to actually make this code work finally. You know, we're going to get back to where we were with that working Pokemon battle. But it's going to be organizing classes. It's going to be a little bit neater, a little bit nicer, a little bit easier to add more Pokemon, right? And this code here, our last code, this here, it is virtually impossible to add more Pokemon. Virtually impossible to add new moves. It's just a huge pain in the ass. You have to change all kinds of shit each time. Thankfully, when you use classes and methods and attributes, it becomes much easier to add in more Pokemon, add in more moves, add in more all kinds of cool stuff. So it's really important as you become stronger in programming to either become very competent at functional programming like this, or to branch off into object-oriented programming using classes, inheritance, and things like that. But yeah, so next week, on the week after next week, we're going to come back to this, take all of our old code, translate it into using classes, and then in the future we can add in more Pokemon very easily. It'd be really, really nice, I feel like. But for now, we kind of have this half-finished code here, but we learned a lot, I feel like. I hope we did anyway. Guys, I'm going to move on to some RuneScape now for the rest of our stream here. As usual, if you guys enjoy hanging out, I want to keep the channel online. Check out my Patreon page at patreon.com/Vencabot. Even a buck is a huge help over there, guys. Every month, it helps me buy groceries and gas and stuff. I stream all the time, so it's very important that I can get some kind of livelihood out of it. But I totally understand, guys. You guys are, you know, like students, or you're working full-time, you have a house to pay off and a family to feed, or you're working part-time or whatever. It's kind of hard to help out a streamer, right? In that case, help for free in that case. You know, in fact, it's the best way to help out. You guys in the chat make it more fun for me to stream. You guys make it more, easier to host, and you make it more fun for people to watch, too. So thank you guys for hanging out. That's the best way to help out. Thank you, Skullcrusher and Mr. Anderson and Zanzu and all you guys for making the stream more fun. Also, you can follow them on Twitch for free. Tell your friends we're here, spread the word, and save clips of, like, funny stuff and scary stuff. Not really for programming, but it's mostly for gameplay. The clips are really cool, guys. When I go on my break here, you're going to see the viewer clip theater, I call it, where I play clips on my break screen. Also looking for sharing on Facebook and Twitter to promote the channel, and on Discord at Vencabot.com. Share your clips there as well. Also, we're on YouTube, guys, at youtube.com/Vencabotarchive. That's at youtube.com/Vencabotarchive. We have all of our past streams archived there, about 1,000 videos, mostly gameplay, a little bit of programming on there as well, some tutorial type stuff. Go watch me programming online Battleship clone on there as well. Yeah, go check out the Intro to Python playlist. We're also on GitHub, guys. Every week we do new code here on Friday, and that code goes onto the GitHub. So you can go read what we did in the past. That's at github.com/Vencabot/intro_to_Python. But, more importantly, join our Discord. Again, it's at Vencabot.com. There's a Intro to Python channel there. You can go read all of our past code there, get the GitHub link, get the YouTube links, ask questions on Discord. I can help you out over there anytime you want. It's very cool, guys. That's at Vencabot.com. Look below my stream for the big Discord button and click it. It's real, real easy. Go subscribe on YouTube as well. I'm putting a lot of work into that, and it's really, really cool, I feel like. I'm going to go a very short break, guys. Come right back with some RuneScape. I'll see you guys very shortly. What a mouthful. Thank you for hanging out, Skullcrusher. Have a good night, homeboy. Guys, it's Friday here. We do like a casual Friday stream. Most of my streams are very structured here. I usually do like a schedule of fighting games and long plays and stuff, and viewers' choice games. But on Friday, we do like programming and then special events. So we did programming just now. Our special event for tonight is going to be RuneScape. And I'm pretty looking forward to that. It's going to be old school RuneScape. If you guys want to join in, check out the Discord channel. You're welcome. It's a free-to-play game. You're totally welcome to join. Let's close all this stuff. He's so Zori. Get him! Due to UMACon being next week on Friday, I'm not going to be here on stream at all, let alone programming. But on Friday the 9th, I'm going to be coming back with more Python. Hopefully in the future I can do Python more than once a week. We've been doing pretty good numbers so far for Python. This will get a lot of viewership, I feel like, on Python. There we go. That sound if that's true of today, I'm going to look forward to hopefully finding a way to add in more time every week. Photo back, I guess. That sound effect vows. I was kind of afraid at first I wouldn't be able to hit him with it, so I missed the first time. Can I get this bat? So I'm already in a good resolution for RuneScape. You should use the bat. Let's see if I can run it and see if it causes any problems. Yeah, guys, by all means, make a character. If you guys aren't ready by the time we start, no big deal. We can always pick you up later. We're going to be streaming all night long playing RuneScape tonight. Oh, it is pretty spooky. I didn't even notice until you mentioned it. You don't like the music, dude? Oh my god, it's so good. How dare you?